Sorry about that. How are we today? Looks like we're the 39 steps. Each one of you guys can be a step in a Hitchcock movie. Tired? What time is it for you, Zuriel? For me, it's 8 o'clock, so we'll be here till midnight if we stay on time for the class, 1 a.m. for Q&A. Yeah, I definitely could have a coffee. But, so where are we? This is the basics of Unity, otherwise known as Unity 102. This is a continuing introduction to Unity and the Unity editor, a class that should last about 4 hours, and there will usually be 3 short breaks. So a little bit about me. My name is Adam Buckner. I have been using Unity since about 2007. I have released 3 games on iOS. I have 2 systems up on the Asset Store, and I have a huge pile of unfinished stubs and experiments because it's so fun to play with Unity. And I also think it's important to know that my background is not in computer science, coding, game design, or programming. My background is in visual effects for film and television. And when my son was born a few years ago, I was looking for some way that I could stay closer to home. So I turned to Unity for real-time rendering and as a games design engine, and I've been happy. Now, it's been pointed out to me, that's a bit of a lie saying I've not done game design before coming to Unity, because I used to photocopy D&D modules way back when I was in high school and sell them. I used to write them and sell them at the local bookstore. So I suppose you can say that, yes, at one point I was a games designer, and I did make money on it. So does that make me a professional? I don't know. So yes, you can use that to date me. Back when, like I said, we loaded our video games off of cassette tape, audio cassette tape. So what are we going to cover in this class? In this class, we'll cover some of the beginning topics of Unity, all in the context of creating a top-down shooter. We will be importing assets, so we'll import meshes and sounds and images or textures. We will create materials using these image textures combined with shaders. We will be writing basic components using scripting. We'll also be using the basics of the input manager, which we didn't do yesterday. We will be using the asset store as part of our pipeline, and then we'll also be building and hosting a simple web player. So by the end of this lesson, we will complete and host a basic game, including controlling our player, moving and destroying our enemies, counting points, displaying a simple UI with score and buttons. Now, a little bit also about how we're going to do this. We're going to be teaching concepts, frameworks, and pipelines today. And as such, we'll be using very simple objects and primitive shapes to get to the grips, to the nuts and bolts of making a game with Unity. Also, at the same time, I hope to show that although game logic and artwork do go hand in hand and work well together, and you do need your final artwork when you release your final game, that you don't need your final art assets when working out the first steps of your game and gameplay. And I think that getting caught up in the look and feel of a game can distract many developers from focusing on core mechanics and gameplay. If you say that, you get to that point where you say, I can't move on to the next step because I don't have my final character, then you're missing some of the best development time that you can. Because if you can make a game fun and interesting using nothing but cubes, then you're going to have a really interesting game when you add your artwork to it. So we've got Angry Bots running, or Angry Bots. This is Robot Lab running in the background. This is the environment that we do a lot of our learning in. It's a nice environment. You can download this. You can use this in your games. We distribute this, but it's primarily just eye candy for today, something to do while we're talking. We are going to be creating another brand new project. Now, I'm not going to be going over anything that we covered yesterday in 101. So if you didn't come to 101, I'm sorry, but I'm not going to back up. We can cover these during break if you're missing something, or during Q&A. So we're going to create a new project, and this brings up the new project wizard. And then we're going to set the path. Let's set this to our desktop. Let's create in this as in a project called Unity 102. And remember, this just sets the path. This doesn't, at this point, actually write any files. We're going to leave it empty. I want a new empty project. Simply hit Create Project. It looks like Unity has crashed, but no, it's just simply writing those files. We can see that those files are now been written to disk, and that we now have our assets directory, and our assets directory is empty. And we can also see that our project is empty as well. So I've got a layout for this. I'm going to cut to the chase and just quickly pick the layout I've made for 102, which is our scene file, our scene view, our game view, and our console, all tabbed over here on one side, and then our project, so our assets, our hierarchy, our instances, and the detailed view of the inspector here on the right. Audio should be on, but you can't hear that if it isn't. I should get this as a quick text, but try the audio wizard in the meeting tab, or try disconnecting and reconnecting. Also, check that the mute button is not on. Okay. So we've got this, excuse me. We have this new project, and this new project is called U3D-102. And we can see that it's unsaved. We have not saved our scene file because it's not. It's still called untitled, and we see no asset in our project. So let's go ahead and save this. Save our scene. I'm going to save this in a new folder called _scenes. Now, this doesn't have to be the way that you do it. This is the way I like to do it because I like to have my scene files sort to the top. And I'm going to call this one main. This will be our main scene. As a matter of fact, I want a capital M on that. And I'm going to do that. Capital M. Oh, that's wrong. Capital M. And then I'm going to reload this scene so that I make sure that I have this one loaded. We can see it's main up there. Before we get started, let's stop and take stock of what we're trying to do. We're trying to make a top-down shooter. The player will work from the bottom up. Enemies will come from the top down. And the main camera will be static looking down on the game board. What I'm trying to do is recreate that same sense of an arcade game, the upright arcade games that used to be in the foyer, the lobby of every sort of small grocery store. And for your sucking your quarters down. You know, and also you could go to one of those great video arcades where you could sit there and get your ears blown to bits with all of the video games that were running around. So it's that same idea. We're going to make it upright. We're going to make it a portrait game rather than a landscape game. So tall and thin with our player working from the bottom up, enemies coming from the top down, main camera static on the game board. And we're also going to be using 3D objects. So it's going to be a 2.5D game. So not a sprite-driven or 2D game. We're not going to be using pixel graphics. We're actually going to be using proper 3D mesh assets so we can look at the import pipeline, but we're going to restrict our gameplay to the plane. We're going to play on the Z and X plane or the XZ plane, and our camera will be looking down on that plane down the Y axis. So creating our game assets, what assets will we need? We're going to need a mesh model. We'll need at least a player ship mesh model. Enemy objects as well will be meshes. We'll need textures, enemy skin, player skin, maybe a background. Effects like weapons, explosions. We'll need some sound effects, weapons and explosion sound effects, maybe a game over sound. And then code. We're going to need code to control our player object, including the input manager. We'll need enemy controller to control our enemy. We'll need weapons controller to control the weapons we fire, and then a game controller to control our overall game, including our UI and our heads-up display. So let's get started by creating our assets, beginning with our mesh models. Yes, and not only will I provide the package at the end, I'll try to distribute these packages at break if I remember. So if you get behind, if you're trying to follow along and you get behind, don't worry. I'll distribute the first package at the break. So do sit back and watch, especially at the first part where I'm going to be creating our mesh assets. So we're trying to find our mesh assets. I could be going to help and then looking at the reference manual or the Unity manual, but there's a little bit of a trick. I can go to the scripting manual and I can search for mesh. The reason for doing this is that if I go to the reference manual, there is no search box, and neither is there in the Unity player manual. But the scripting does have a search box. This will be changing when we change our documentation, but at this point, we'd have to be using the page-based, sort of find on a page search. But if I come here to the scripting overview, I can search for mesh. And this brings up the mesh class. Now, if we wanted to, we could be creating our meshes procedurally here inside Unity using scripting. I just don't recommend it unless you really, really know what you're doing or have a very specific use for wanting to monkey with the mesh directly. I would suggest that you deal with mesh modeling applications to get your meshes and then import them as assets. But the big advantage of this, not only does it let me show off the class so that you see that you can build a mesh from scratch, but also remember this from yesterday, you can switch from scripting to the component reference. And this gives us our component page on mesh, which is ultimately what we want to be doing. Now, there are two main pipelines for dealing with mesh assets. Unity supports all of the major mesh modeling applications: Max, Modo, Maya, Blender, Cinema 4D, and more. And so we can read those proprietary 3D application files directly. We can save a .max or a .blend file directly into our assets directory, and then Unity will be able to read them. Unity also reads exported 3D file formats like FBX or OBJ files. There are some advantages and disadvantages of each pipeline. I find that small groups usually run with proprietary 3D application files. And this is because it's relatively quick. You can be in your 3D application. You can simply save their proprietary file to the assets directory or any subdirectory in the assets directory, and your model will be imported. The drawbacks to this is that you could get some file bloat because you're getting the full file and all of the information that the mesh modeling program is saving. Also, you need to have a licensed installation of that application on the same machine as your project, because Unity actually uses that application in the background to run the import. It just basically powers up the application in the background, has it look at the file and has it do the export, and then closes it back down again. So if you're trying to pass on a Unity project or a Unity package that includes those models, and those models are a .max or .blend or whatever proprietary file type, the other people won't be able to load that up and run it unless they have the same application on their hard drive. Now, in larger companies and larger studios where you've got usually a separate art department and you have a separate game design department, and they're all linked together by coordinators and producers, often I see that FBX export-import pipeline. This can be very efficient on a certain level because your artists have all of their assets controlled in the way they like to work, and they simply hand the final FBX file over to the producer or the coordinator or the game designer to incorporate in the scene. But I mean, there are some drawbacks to that as well, which is that it can be a slower pipeline for prototyping and iterations. You can lose track of which FBX is this. Is this the most recent? Is this the next one? You have to find a way to replace it or overwrite it into the assets directory without losing track of which version you have. So there are drawbacks to each one. They go into the details on this page. The mesh component page will go into the two pipelines a little bit more deeply. But you can sort of start to see how these two different ways may depend upon how you like to work your pipeline, whether you've got that exported 3D application file or whether you're doing the proprietary 3D application file for moving your meshes around. And we will see both of these in action. So let's go ahead and make some mesh assets. And for that, today we're going to use Blender. Blender is a free mesh modeling application. You can get it at blender.org. It's an open source modeling application. It's usually as powerful as the ones that you pay full price, with the exception of being maybe a year or two behind. But many people find that they're not updating and upgrading their big full price applications as much as they need to. And so I find that I've never had any problem with running in in Blender. 2 seconds. So let me reload that startup file. Here we go. And then let's delete that cube. We're not going to be teaching mesh modeling today, but I just want to do this as an example so that you can get a feel on how you can create meshes and create mesh models and import them into Unity. So for our player ship, I'm going to start by creating a cone. I'm going to add that cone, and then I'm going to reduce the number of faces down to 6. So I now have a very simple cone here, and I'm going to move into edit mode here, and then zoom in. And then I'm going to scale this model, but only on the Y, down to about 1/4. And that gives us a very simple little wedge. Well, do you know what this is going to be? This is going to be our player ship. So I did say we were going to be using simple mesh models today. Well, there's our simple representation of our player ship. Now, to get this into Unity as a proprietary file type, we can simply just do a file, save. I can save this on my desktop into U3D-102 and then into my assets directory, and then change its name to player ship. So I now have player ship.blend, and I simply save the Blender file. If I come back to Unity, we can see that Unity detects that there has been a change to the project, to the assets directory, and it imports that player ship directly. If we go ahead and look at our assets directory, look at Unity 102, and then look in our assets directory, we can see we have that player ship.blend. I'm dealing with that proprietary blend file directly in my assets directory, and we can see that it has been imported into the scene. So we can actually see that player ship in our import settings. Now, the import, as we noticed, did also create a materials folder. We will be discussing the details of the import settings, which is what we're seeing in the inspector when we look at the asset, and we will be discussing materials later on. Let's now just take a look at this imported model in our scene. So let's drop that into our hierarchy, and we can see there it is in our scene, and here it is in the inspector. Now, if we come back to Blender, we can see pretty much same model and looks the same here in Unity. There is one little difference, though. If we take a look here in our transform rotation, that there is a correction in the x-axis by minus 90 degrees. If we zero that out, we suddenly see that our ship is facing in a different orientation. Why is this? This is because the default orientation of the 3D volume of these two applications is oriented differently. If we notice that Unity has X and Y as the plane in front of you, and Z is depth away from the camera, in all cases that I've seen dealing with 3D voids, 3D volumes, X is always left and right, and Z is always depth. But where is that depth? Is it away from you, like you're standing in front of a chalkboard and you're holding your hand straight out in front of you? Or is Z depth up and down, which is the way that it is in Blender? Now, when it comes to orientation and volumes, and we see that also with points and spaces themselves, this orientation is essentially arbitrary. And the people making these applications just need to pick some arbitrary orientation for their game package. And you'll discover that your packages, whether it's Unity or Modo or Blender or Maya, either have one or the other. I've never seen X, like I said, anything but X and left and right, but where the orientation of Z and Y is can change, and sometimes you can change that in your settings. So you should double check your mesh modeling application to see whether or not you can change it. It's hard-coded in Blender with Z up. Modo is hard-coded in its application to be Z away, which is the same orientation that we have here in Unity. So for us, coincidentally, this orientation is good because we want our ship to point and play and fly along the XZ plane. So this is good for us. But it really is coincidence, the fact that this orientation is just different between these two packages. Now, I also want to make a change. Let's talk about making changes to our mesh models in this pipeline. Remember, we're dealing with a proprietary file. This is the .blend file. And the center point of the model is the same whether let me just change this so that you can see that around the center point. There we go. The center point of the model is the same as the center point in the 3D package. And you can see that we're rotating around that center point in Unity, and that center point is set here in Blender as the center of the Blender volume. I don't like this. This makes me a little bit uncomfortable. I'd like it to be further back, more towards the center of mass. So let's see what it looks like to do a change to a proprietary file. Let me restart my startup file here so you can see that this isn't already loaded. So if I want to make a change to a model and it's a proprietary file type with a .blend, I can simply double click it in my assets directory, and you can see it's went out and finds the application, it loads the file into the application, and there we have it ready to edit. So I'm going to grab this model, I'll grab it on the Z, and I'll lift it up by half a unit. And then we can, we won't save that just yet. Habit, save early, save often, that was habit. So there's so there I've moved it up, and let's go ahead and make another change. Let's add a sphere to it. Let's add a sphere, and let's scale this down to 1/4, and then let's grab it on the Y and move it up, I don't know, just a little bit so that it sits at the top. So there we go. We now have a canopy for our pilot. Let's grab this at the end as well, grab it on the Z, and then bring it back down a little bit. So we have a little bit more of a sexy shape. So it's not quite a dull-looking wedge. So we've made these changes, and then we can simply just say, I want to save. Just save it. Come back to Unity, and we can see that that center point has changed, and that we now have the change in the mesh and the change in the sphere. So we can simply make our quick changes. So this is a very quick file pipeline. We can save it into our assets directory. We can double click it. It loads it into the application. We can make our changes. We hit save. It comes back again. One of the drawbacks is that you can see here we've got this funny little extra file. What is that? That's a auto save by Blender. So one of the other problems that you get is, bloated file types. It's got all of the information that Blender wants about its files. It's doing its auto saves in the same directory as the original mesh model. So there are some drawbacks to this particular pipeline. Each application is slightly different, and this particular symptom is one of these from Blender. Let's talk about the excuse me, the FBX import. So if we want to do an export of an FBX file, let's come back to Blender and make some additional changes and then import this as an FBX. So the first thing I want to do is create a cylinder, and let's add a cylinder to it. And we don't need these many faces. Let's bring the face count, the vertex count here from 32 down to, I don't know, 12 is probably enough. Remember, we're always going to be balancing our performance budget with our quality for the game. And you always want the highest quality that you can get, but you also don't want to have a game that looks absolutely gorgeous in still frames or cinematic trailers, and then people get to your game and they find it absolutely unplayable. So you have to always remember to balance that out. So if you don't need that amount of detail, don't put it in your game. So let's change the radius down to 0.1, and then its depth to 0.5. And let's grab that. Let's grab that on the Z axis and bring that down a little bit, and then let's grab that on the X axis. Then I'm going to duplicate it and then grab that on the X axis again. And so I now have some engines. Now this is going to be silly. We'll probably never see these guys, but let's grab them anyway on the Z axis and just sort of punch them in a little bit. So there we go. Slightly more sexy ship. Protocol says we should save at this point, but I'm not going to, because if I save at this point, the changes will be saved to Unity, and we won't see the difference between these two ships. So I'm going to violate protocol and simply do an export as an FBX, but before saving, which is not really the best idea, but it does for our purposes today help us out. And then I'm going to change this from playership.fbx to playershipfbx.fbx. And I'll explain why I'm doing that in a second. So let's come back and look at our import into Unity, and we can see that we have our player ship, and then we also have our player ship FBX, and you can see we've got our little engines down there. So let's drag that into our scene. So they're both coexisting in the same space. Let's correct that 90-degree correction, the 90-degree offset that we have in X, and then let's move the player ship out of the way. Where's our FBX file? Down there. Okay. Frame selected. Very, very tiny. So, in one sense, this shows very easily how quickly we can do our FBX export. We also see that something isn't quite right. I don't want to go into the details of the import settings, but let's go ahead and take a look at the import settings for just one particular value. And that's scale factor. If we look at player ship, we can see that it has a scale factor of 1. If we look at player ship FBX, we can see it has a scale factor of 0.01. If we correct this and make that 1 again, and then apply, we'll discover they're both the same size. Probably bring that player ship over a little bit instead of 3, about 2 units. There we go. So why did the FBX come in at 0.01 and the blend file come in at 1? Well, this comes back to the arbitrary nature of meshes. We just need to know their association with each other, how they are relatively faced to each other or spaced to each other. So just as much as your mesh modeling application can pick an arbitrary orientation for its XYZ coordinates, a mesh modeling application also picks an arbitrary scale when deciding how far apart these points are, these vertices are inside the mesh modeling application. Now, Unity in general defaults to 1 Unity unit to be equal to 1 meter. And this is primarily based on the physics engine. That's tuned to 1 Unity unit to be equal to 1 meter. Now, it really depends. There is no better or worse way. It depends upon how you like to work. I'll answer that question in a little bit more detail in just a second. Let me finish about scale, and then I'll come back to that. So, but there are many mesh modeling applications. I think Maya and Max are both this way. Often, if you end up with something that would export an FBX file, they were using centimeters. They use centimeters as their default scale factor. So if you model something in Max or Maya, the assumption is that you've been scaling, that you've scaled this and modeled it with centimeters as your default. And so it's going to, the automatic importer, since it has to pick some value, will scale it down to 0.01 of its size, making the assumption it needs to correct for centimeters to meters. Now, how to use scale best? The best thing to do is to set the scale to whatever you want it to be, to whatever you need it to be in your original mesh modeling application when you model your mesh. So pick units as, if it's coming into Unity, pick your units to be meters and scale it all up to meters so it comes in at a 1-to-1 level. If you don't have control over that stage in your model, say you've purchased something from the asset store or Turbo Squid, or you've brought something down from blend swap and it's done in centimeters, then the next best place that you can set it is in your import settings. And realize that this is a float value, so you can set this to be any float value you'd like it to be, and then on save or on apply, it will scale that up. Now, this doesn't mean that you can't scale things in the scene, which you can. You can scale things in the scene, so you can simply pick scale and scale it up. But it's not the most efficient or recommended place to do it. So if you've got something like a spaceship that's or a car that's a hard-bodied model, and you won't get different variations of it, scale it in the mesh modeling application or in your import settings. Now, if you have something that's more organic, an example would be there is a very popular MMO that has a very large crater filled with jungle plants and dinosaurs. There's a little volcano in the middle. And there's little tiny dinosaurs that are very close, and medium-sized dinosaurs in the mid-ground, and a very big white dinosaur that can come along and stomp you flat. It's the same model. They've just simply changed the scale in the scene. As a matter of fact, the texture scale is the same too. So sometimes there is a problem when you quickly scan the horizon. Is this a small dinosaur very close or a big dinosaur far away? Hard to tell. When the big white foot comes along, it's pretty obvious which dinosaur it belongs to. So feel free that you can change your scale in the inspector for that particular game object. Maybe. Yeah. Just a good example. But you can change that, but if you don't just fix everything in the inspector, do it in the import or do it in the original mesh modeling if you have the chance. Now, why did I name that FBX explicitly? Let's take a look at our Finder again. Note that we had playership.blend, and we could have had playership.fbx. And they won't overwrite each other. Unity, on the other hand, has some things that I really, really like. It simplifies and makes our project look very nice, very neat. We don't see the extension values. We don't see .fbx. We don't see .blend. It takes us sort of out of that computer directory feeling like we're looking at our hard drive at our desktop level in our Explorer or a Finder. But where this can be a problem is you could have two imported objects, both with the same icon and the same name, and we wouldn't know which was the FBX file and which is the .blend file. And so being aware of that, I made sure that I appended FBX as part of the name so that I could see it. So let's do some quick cleanup. Let's get rid of that. Oh no, let's go back here first. We haven't saved our scene. Let's save this. Save over our playership.blend because we want that .blend file to be updated correctly. Now we're going to have two stubs when we do our import. So let's just clear these out. And remember, we don't want to clear these out from the Explorer level or the Finder level. We don't want to do this in our operating system. We want to do this here inside Unity. So I've cleaned those up. Let's create a new folder called Models. Let's put in the player ship and the player ship FBX. And then I'm going to leave the player ship FBX in the scene and get rid of player ship, because when I distribute this to you, if you don't have Blender, you won't be able to import that .blend file and you won't be able to use the model, whereas I can use the model for FBX. So I mean, I'm not really recommending whether you use proprietary files or the FBX files, but you should be aware of the differences. Certainly if you're distributing your package like I am here, use an FBX file. When I work for myself, I simply use a Modo file or a Blender file because I find it much more efficient. And when I do use the FBX file, I always keep my .blend or my I think it's LXO, my Luxology file, in my project somewhere so I know where it is, because I'm dealing with my own projects. If it was in a big production facility, you probably would have all of that material in the art department. It would probably never come into the project at all. So let's talk about our mesh import settings. Looking at the FBX file, and then I'm going to duplicate this with the, well, maybe not. I guess we don't need to with the blend file. So we'll just deal with the FBX file, because that's the one that's going to go into our scene. So the import settings determine how this asset is going to be imported, and we have some choices. When we're dealing with our meshes, we've got 3 tabs: Model, Rig, and Animation. That's new in 4.0. If you're used to 3.5, it's just one big importer. But we've now split out the rig and animations, and this is primarily to support Mechanim. Now, I'm not going to go into all of the settings in detail. If you really want to get more information, you just click on the book, and that will load the documentation so you can read up on it. But I'm going to go over some of the main ones that we need to worry about. We've talked about scale factor. Best to come in at a scale factor of 1, or to correct your scale factor here so that all of your instances are 1-to-1 in your scene. If you want to, you can generate colliders, especially if you're dealing with static geometry and you want to generate colliders. Again, I think you should make your simplified mesh colliders in your mesh modeling program, but if not, Unity can do it for you. Same with if you're doing light mapping. Best to do that, create your second UV set in your mesh modeling application. If not, Unity can do it for you. Normals and tangents, if you should, sounds a little bit like a broken record, you should do this inside your mesh modeling program, but if not, you can have Unity calculate them for you. We haven't affected our normals at all, so we're going to let Unity calculate this for us. Normals will essentially help smooth surfaces, so we can set the value when we have it calculated. 60 is the default, which basically means if an angle between two faces is less than 60, Unity will consider it a smooth surface. If it's more than 60, it's going to be a hard edge. And then the last one is importing your materials. Importing is a little bit, sometimes can be misleading. We don't ever import specifically materials from another package. Materials themselves don't import. Because architectures of materials between different applications are always different. But Unity will try its best to find either a matching material, or if not, a matching texture, and in which case it'll create a material that will then work with your model. And then how you do that, you can set here in these menus. For more information on that, I would strongly suggest you read the documentation, because it's relatively complicated and it's more than we can go over now. But just realize that if you want to bring in materials that you've made in your mesh modeling application, they won't come over completely one-to-one. We have to create new materials, and this is how you match them up with material that you have inside your project. So when we're done, we can hit apply. We'll see that there is a preview of the imported object here. And then at the bottom is a preview of what that model would look like. So let's go ahead and hit apply. And we can suddenly see that that surface has become very nice and smooth, nice and rounded. And that's because this angle down the middle is less than 60 degrees. So it's smoothed out this entire surface. When it comes to rig and animations, notice that our little preview shows an animator controller. We don't need that. Let's talk about rig and animations. We have what I like to call a hard-bodied model right now. We've got a spaceship. It's not animated in any way, but Blender has given us a default take as a clip. And this default take has no information in it. Essentially, it's not. And snap it to the origin or 0 point of our game world. So it might look that like all of our models simply disappear or cluster there in the middle of the game world. So if we don't have an animated model and Unity is trying to import an animation, there may be some sort of aberrant information or default take. So don't import it. Make sure that you turn off import animation if there are none. Same with rig. Humanoid rigs are humanoid T-posable 2 arms, 2 legs, and a single head that you can use with Mechanim. And this is our Mechanim animation state machine. If it doesn't have that humanoid shape, you can get Mechanim to drive the animation using a generic rig. And Legacy is our 3.5 and earlier style of animation. And we want none, because we don't have no animations, no rig. And so if we come back and look at our model, we can see it's simply that mesh filter holding the cone mesh and our mesh renderer rendering it. And that's what we see in the updated model now that we've updated our import settings. So when that mesh was imported, a materials folder was generated. Think. Unity will try to find a material when importing a model, and it'll try to find and associate a material by name or by position in the hierarchy. Again, read that piece in the documentation. If not, it will create one. Let's take a moment, and I want to talk about materials themselves before we talk about how materials work in the import pipeline. And we're not going to be discussing any procedural materials or substances today, because they're really beyond the scope of what we're doing. Now, Materials, these describe how our game object will be rendered. Unity needs a material assigned to any mesh to be able to render it. Materials do not transfer from one application to another. We can try to match up existing materials with from one application to another, but essentially they're being recreated inside Unity. Now, UV maps, or how those textures are applied to a model, do transfer from one application to another, and they come through on that mesh package. And we must always reconstruct our materials when we import our mesh. So taking a look at this default material that was created when we imported our spaceship, it's called no name, and that's because we didn't force create a material in Blender, so Blender also can't render anything without a material. So it just created a no name Blender material and included that reference inside the file. So when Unity imports it, it tried to find something that we've built called no name, which we haven't done. So it builds a no name material and then tries to find a texture, which there was none, so gives us an empty material. Now, materials like this one, a very basic material, it's made up of a shader, a main or tint color, and a base texture. Now, some shaders will expect additional texture layers, but they aren't used usually to overlay or mix with that base layer. They're used to process that base layer. They can be things like bump maps, normal maps, or specular maps, highlight maps. So if we were to change this to, say, parallax specular, you can see that we have a number of additional slots for more textures and some more settings. And these aren't going to be used to texture our model. They're going to be used to process that texture. So what is this shader? Super simply put, a shader tells the renderer how that texture will behave on our model. In a little bit more depth, the shader is a little script that we write or that you get pre-written for us here at Unity that programs the GPU or graphics processing unit just before being sent the texture for that model. And it's the shader that determines what properties that we need. And actually some really simple shaders don't even have main color and base texture. Most shaders require at least a main color and a base texture. In this case, the main color will tint the final image. Full white is usually normal for this. It's often normal. But I've seen some shaders that are based on other values. I've seen shaders where they're based on 50% gray as the main color, and then your main texture will look perfectly fine if the main color is 50% gray. But then when it comes above 50% gray, it starts to overexpose or overbrighten that material. If it goes below 50% gray, it'll sort of underexpose or darken that material. And that's all about how that script code is written inside the shader. Now, base textures, they're the image being processed. And it can be none. If it is none, like we have in this case, it's simply the base tint color that's being used to tint the model. So that's why our model is a gray form of white. And then all of those additional layers are used by the shader to process that base texture image. Yay for open windows. I'm not sure if you can hear that. It's baking here, so I'm sorry if there's too much road noise outside. But otherwise, I would rather be in Sweden than be doing this in a sauna. But so there are some windows open here. I apologize. So let's take a look at our materials just very quickly in the documentation. And this goes over a lot of what I just said, shader and a main color and a base texture. But I mostly am doing this to find the link to the built-in shader guide. And also, we can look at the links to the shader section and shader lab reference. The reason for this is that built-in shader guide talks about all of the different shaders that we have built in. It's somewhere between 80 and 100. And each one is slightly different. There's also a line on the performance of Unity shaders, so which is most important, which is the most performance, and what layer and level that they are. And you can see unlit, it's just the texture, not even affected by lighting. If you want to be doing like a really cartoony 2D game, you can use unlit textures and you can have no lights in your scene. vertex, lit, diffuse, normal map, specular, etc. More and more complicated, more maths involved, more calculations, the slower your game will run, but often the better it will look. Again, our balance between performance and quality. So take a look through the built-in shader guide. You can see that they're like in the normal shader family. So we can pump these up here so you can see them. What low-res images. I still haven't found the best way to show these off. If you look at vertex lit, you can see that there's just a cube with a texture on it. And then you can go to diffuse. It's got slightly more, slightly softer feel. Then specular, you can see it's got a highlight to it. And then bumped. These aren't real. Look at the edges, razor sharp. But this bump map is telling the graphics processing unit how to light this with fake lighting, so it looks like it's got some relief to it in the mesh. But the mesh is really simple. This is just still two triangles. And then you can start having more complicated one. This is bumped and specular. Then the parallax, diffuse, bumped and specular. So you can keep going to more and more complicated, adding decals, etc. So each one of these are different. There's transparent ones for glass. There's cutout ones for doing like chain link fences. Lots of different choices. And you can write your own. So if you look at the shader section and shader reference, you can start to write your own little programs. And it's not that complicated, but it is a different layer, different language. Yeah, like cell shading, you can write cell shading shaders. You can write shaders that look for the outside edge. I was playing some Guild Wars 2, and their targeting reference basically looks at an object and draws a red line around the outside, and that's in the shader. And then if you don't want to write code, take a look at the asset store and built-in shader editor. And there are several visual shader editors that you can have here. Shader Fusion. It's not cheap, but I gather it's good. Strumpy Shader Editor is open source. It's free, but as being an open source file or project, it has the pros and cons of being open source. So come here and look at the asset store, decide which one is best for you, for your price and your budget and solution, and you can start to make your own shaders without using code. We can talk about how to do that in either Q&A or halfway through or during a break, how you can create a bump map from a single texture. Unity can help you with it. Again, you should make your own normal maps, not have Unity do it for you, but Unity can create one from a grayscale, which we can show during Q&A if we don't get a chance to do it during class. Excuse me. So materials. Once we make these materials and they have the shader, and then we add our texture to it, we then use them in our models. So materials are used by the mesh renderer here in the materials slot. Now, this materials list, well, it's just that. It's in a list or an array. So you can have many different materials in this list. And each slot in this list or array is for one set of UVs or one submesh on your model. And a single mesh can have multiple UV sets or multiple submeshes, and you need one slot for each submesh that you have. If you are missing, if you have a submesh and there is no material for it, it simply won't get rendered. And then coincidentally, if you've got too many materials, then the last slot in the materials list, or I mean the last slot in the last submesh or the first submesh, I can't really remember, will get overwritten by all of the extra materials at the end of the list. So if you want to, and mostly it's a mistake, but if you want to, you can use this for doing sort of hidden multipath rendering by putting 3 or 4 different materials into your materials list and having it over-render that same object multiple times. How do we get these UV sets or submeshes? UV sets are created by UV mapping your model, and you have to do this in your 3D your 3D modeling package. UV mapping is a process of applying a 2D texture image onto a 3D mesh model object. This creates essentially a matrix to map the 2D points of the texture onto what is ultimately these flat 2D faces on your model. And you can have multiple, like I said, multiple sets of UV maps on each model, even if it's the same mesh. And each one of these UV sets or submeshes needs a slot in the materials array. So let's take a look at this basic material and see that in the inspector. And we don't have a texture, so let's just call this color only. Learn to type. So this is our color only. And we can see that if I change the color, I'm simply changing that main color. It's tinting my non-existent base image. And so I'm simply coloring the model using that base tint. If we look closely at this model, we can see it looks like it's made of a material that's been painted with a really fine matte paint. If we wanted it to look different, we can change the shader. We could make it specular. And now it's starting to look a little bit like it's made out of plastic. And we can, crank up the shininess a little bit. And now it starts to look even more like plastic, like it was made out of a Lego brick, a flat Lego brick. And we could change things like the highlight color. And now it looks like we're lighting this with a purple or a magenta light, or a yellow light. And this is where things get interesting with materials. The reason why they're called materials is that it looks like this is made out of a different material. Now, this is not being lit by a yellow light. This is purely by tinting the specular color, the highlight color. So you could do something funky, like Excalibur, where he always used to shine green lights on people in bright, shiny armor. So you could have a character that strode around the scene in silver armor, except the highlights were green. And you wouldn't need to put a green light on him. It'd be part of the material of his outfit. So I'm going to set this back to 128 here, just so we know what they are, and leave that there attached. Now, if we didn't have any material slots, we can see that it doesn't render. So you need to have at least one material there. Echo, we can talk about that in Q&A or during break, because there's some good stuff, but I can't really back out of class to talk about that right now. But cool, remind me during break or during Q&A, and I'll give you some resources. So our materials also require something assigned. If we have a slot for it, but we don't have a material assigned, we get this emergency pink color. If you see that pink color, it means that there is a slot available for the mesh, but there is no material assigned. And we can assign it by dragging it. And you can see that just by hovering it over, we get a preview. We can drag that onto the model in the scene view. We can drag it into the inspector. I'm going to undo that. We can drag it onto the game object. But we should note that when we do this, no matter how we do that, it will only ever populate that top slot. It'll never do any of the additional slots underneath. So if you have more than one slot, you then have to grab and populate the slots by hand. So let's create a texture. So far, everything we've done is without a texture. It's been textureless. So let's create a texture. And today I'm going to be using Photoshop. Now we could be using GIMP. Yes, thank you. Thanks for the post, Bishop. We could be using GIMP. We could be using any paint program. I just happen to use Photoshop because I own it and I know how to use it. I was going to do this in GIMP when I originally planned the class so I could have free Blender and free Unity and free GIMP. And frankly, it was gimping my head, learning just another program. I mean, there's just so many programs to learn. So you'll have to forgive me for doing this in Photoshop. Just realize that you can do this in any paint program that you want, or the paint program that you like. It's a little bit like when we do mono develop, you can use Visual Studio, that sort of thing. So let's create a new texture, and I'm going to make it 256 by 256. That looks good. And remember, oh, other monitoritis, come on, there we go. Our platform, our performance to quality ratio, our balance. I could have made this a 4K texture. Unity would read it, but I mean, we're not going to go we're not even going to be presenting the game anywhere close to that resolution. So unless you really have a good reason to have a very high resolution image, you should just be careful that you're not overburdening your game and your game engine with something that isn't needed. Because even though it can be swallowed, even though your performance is still high, everything that you're doing is going to take, every time you push your quality, it's going to pull away from performance, and you need to find that best balance for your game. So I'm going to make a very quick texture. You're going to see that this is very similar to the spaceship that I made. I'm going to quickly make some noise, add some noise there, and then I'm going to give it some motion blur. Whoop, motion blur. And what do we got? We've got stainless steel. Woohoo! So there's a quick stainless steel. So I'm going to save this. I'm going to save this to my desktop into the U3D-102, into my assets directory, into a new folder called images, and into another new folder called textures. And again, this is the way I like to work. If you'll notice that yesterday we weren't that pedantic about how we organized our project. We were pretty good about organizing our hierarchy, but today I'm going to be very pedantic about making sure that we have a very organized project as well as as an organized hierarchy. I don't need this one to be seamless, but yes, you could be making this seamless, but I don't need this one to be seamless today. So I need to save it. What are my file formats that I can save it as? Photoshop and TIFF files. They both support layers, and Unity will respect those layers. Those layers are not available at runtime. These layered files are flattened on import, but the original layers are maintained. This means that we can turn our layers on and off without loss during edit time, but at runtime, we don't have access to those layers, and we have a flat file. In general, imported assets within Unity are optimized for the editor and the current build target. But the original asset file is never changed or altered. And this is true for, in general, throughout Unity. So our file format types can be Photoshop and TIFF files with layers, JPEG, Targa, PNG, GIF, BMP, IFF, PICT files, which are all flat files. Most files support transparency, notably with the exception of JPEG. And they all should be pretty easy to save from any of the main paint programs. So let's go ahead and save this one as player ship.psd. It's a Photoshop file in our textures folder. And then we could come to Unity and we can see that we have images, we have textures, and then there's our player ship texture. Yes, you can do mip mapping. Color profiles, not that I'm aware of. And vector formats, not that I'm aware of yet either. Though I have seen some third-party people talking about it. I know that the people behind Vectrosity are talking about being able to bring in vector formats as a plugin. And I wouldn't know if there aren't already some vector formats on the asset store. Remind me during Q&A and we can have a look. But in general, right now, our materials are designed around using bitmaps. So if we look at this, we've got another importer. This is our texture importer. And the first line we see here is texture type. And each one of these, with the exception of advanced, is a preset. If we go to advanced, we expose all of the possible settings. Wrap mode, filter mode, an ISO level, mipmap filtering, whether we want to fade out our mipmaps, border mipmaps, all of these, whether we want to force a power of 2 or leave it as a non-power of 2, whether we want to generate a cube map. And then we can also look at all of the other possibilities, including creating a normal map from either importing a normal map or creating it from grayscale. So if we wanted to, I'm going to quickly just do this so that we can have a look. I'm going to revert that setting. I could duplicate my asset and make it a normal map. And then I could import this one. Whoops, I can import my main player ship as a texture, and then my player ship NM as a normal map and create it from grayscale, and then give it, some bumpiness level. And we can see now it's a normal map. Not necessarily the best way to create a normal map. It probably would be better to have, had a 3D model and then bake that normal map in, or various different ways that you can make a normal map by hand. But in this case, I'm simply taking that um, grayscale image and I'm creating a bumpy normal map from it. So one of the most important things, you can find out about all the different presets in the documentation. I'm going to have a texture. I'm going to leave it here, not take an alpha from grayscale. You can also create an alpha channel from grayscale. So if you have something that's on a black background, you can simply knock that out by saying alpha and from grayscale and then use it on a transparent shader. But what I want you to look at down here is these overrides. There is a default setting for max size and compression. All textures come in by default compressed. And you can set the default values here under default, and then you can override them on a per platform basis. And this is part of this basic concept that Unity has, that you can have one project and one code base and deploy to all of your platforms. So you don't have, forks or splits or spurs of all of the, or branches of all of the different versions of your project for different platforms. You can, if you want to, do it all inside one project with one code base and deploy to all of your different platforms. And so what you want to do here is we can set our compression level, and we can see that we have in our normal sort of preset here as texture, we can pick compressed 16-bit, and we can see the numbers down here are changing. True color, we can see that with true color, we're 256 by RGB 24-bit, and we're using 256K in our project. At 16 bits, 170K, compressed 42K, and it tells us the compression here, DXT1. If we're in our advanced, we have full control over the type of compression. But in general, it's usually best to leave that up to the preset that you're dealing with. Now, max size is literally that. What's the max size? We can see that we've got 256 by, our max size is 224. It's not making our texture bigger. But if we wanted to make our texture smaller and hit apply, we can see it's now 128 by, and it's only taking 10K. We could put it down to the size of a thumbnail. It's now 32K, 32 by, and taking 0.7K. So you can use this, these settings to change the way that the texture is being used in your project. Now, some people like this. Other people would rather do the change in size inside, say, Photoshop or their paint program first, so they have more control over how it's being scaled. But where this becomes very important is when you're going to cross-platform. So we could leave this at, say, 512, something bigger than it is, and it'll be 256 by. And I can leave this as uncompressed true color. But I can override that value. Say I won't do that for my web or my downloadable, but I go to iOS, I can override that value and make it not 256, but 128. And I can give it a 16-bit, make it a 16-bit image. And we don't see this updated because this is the current import settings, and we aren't set up for iPhone. We're simply set up for PC, Mac, and Linux standalone. But when we change our build target, it'll re-import this this image and apply these settings to it, and then we'll get that compression and that reduction in size. I can be even more brutal when I go to Android and say I want it to be 64K. I want it to be compressed for fast, and hit apply. And we can again see no change here, but if I then build for Android, I'll get this hyper reduced, hyper compressed image for this. So let's create a new material. If I select a folder or an item, when I create my new material, it'll be created in that folder or that item. If I didn't, it'll just be slammed to the root of my project. Let's call this player ship, and then let's add our texture to it. Now, if we wanted to have a bump map, we can make that bump diffuse, and we can grab that normal map, and you can see now it's bumpy. So there's our bump map. No, because smaller image sizes, as long as they're still square, they still say same ratio, it'll still work because all of these things are relative. I mean, it may look funny because your resolution's really bad, so it look blurry or chunky, but it should still map properly. So we're going to go back to our diffuse. And then let's take our player ship material and put it on our spaceship. Why don't I see my texture? I can see it here. There's my preview. It's in my texture is in my material. I can look at my texture. It's default. It's not. It's true color. But I don't see my texture on my ship. Why is that? That's because we have not UV mapped our ship. Unity has no idea how to apply this texture to this mesh. It hasn't been unwrapped. So essentially, it finds the very first pixel. And I honestly can't remember if it reads the top left or bottom right first, but it's going to read every one of these pixels in order in rows and columns. And the very first pixel it finds, it applies to the entire ship, because otherwise it has no other way of knowing what to do with it. So let's UV map our ship. Now, remember our pipeline. So let's come back to Blender, and I'm going to reload that new startup file. And here I've got a kind of a hybrid system going, haven't I? I can double click on my player ship, and this brings up the player ship, but this is not the model we have in the scene, is it? Again, I'm not teaching mesh modeling today, so we're not going to go into a lot of the details of what we're going to do with UV mapping, but we'll do a couple. Back to center, please. And then, so we've got that. And so we've got our ship, and we've got our mesh. The first thing we want to do is pick the mesh that we want to UV map or unwrap. And so I'm going to select everything except for the canopy. And then I'm going to pick my unwrapping tool. And we can look at each different one. Each one of these are different attempts to find some way to flatten out this surface. And in one sense, like I said, it's like wrapping a complicated Christmas present. But what you're doing is you're taking that that map off of a globe and trying to lay it flat onto a desk or the skin of an animal and lay it flat like a rug without too much distortion. And all of these are different attempts at trying to find some way to make it work within the bounds of your game. So what we're going to do is pick project from view. And this is a lot like taking an overhead projector with our texture and just projecting it down on top of the model. So, and there's a little trick that I like to use here. If I go to image, open image, I'm going to associate my UV map here, and I'm not really making materials properly inside Blender. I'm kind of doing a trick, but you can get this idea. So I can go to my desktop, I can pick my project and drill down till I find my player ship, and then associate that with my UV map. And if I come to textured, we can see that that has that UV map there associated with it. Now I'm going to do one other quick thing in Photoshop so I can repeat this. I'm going to create a new 2x2 image, and then I'm going to make it black. And I'm going to save this in my images in a new folder called colors, and I'm going to name it black. And then when I color my canopy in Blender, I'm going to do the same thing. I'm going to pick the canopy, and then I'm going to do another unwrap, and then I'm going to open an image, and the image I'm going to open is going to be my black PSD. And we can see here I now have black. I've kind of cheated and forced Blender to make another data block, another material here. So then I'm going to save this to my .blend file, and then so it gets into my scene, I'm also going to export that FBX and export that over that FBX file. come back to Unity, and then I've got these stubs here. What's funny is my canopy's disappeared. Well, that's because I only have one slot, but I now have two submeshes, the body and the canopy. If I look at my imported FBX, I can see that in the preview, it wants two slots. So I've got two choices here. I can then just create a new slot here and then populate it, or I can just revert to the prefab, and it'll take that prefab information from the imported asset, and we can see that that slot shows up. Unity on import has created us, it's found player ship because it associated it with the same name and then created a black material for us. So I can dump that new materials folder. So you can see it found player ship, but it created black because it didn't exist. And let's make black specular. Woohoo! So we now have a shiny black dome for our spaceship. So sorry, looking at that, what does UV stand for? Yeah, exactly what people are saying. It's about the same as X, Y, and Z in 3D space to a degree, but it's UV and W, and people just talk about it for the first two letters, UV, W, X, Y, Z. Yeah, exactly. CJF really has a good answer. So let's quickly talk about changing our texture and looking at that texture pipeline, and then we can take a break. So if we can look at that player ship texture, I'm going to come into Photoshop and I'm going to close these guys down so that we can see. If I want to make a change to my texture, I can double click on that texture file and you see it's loaded directly into Photoshop, and then I can make my changes. I'm going to add a new layer just so we can take a look at layering and how layering works with Unity and Photoshop. And then I'm going to put in a new guide vaguely there in the middle, and then create a new color. So what's a color? I need a color. Somebody pick me a color. I need two colors. First two people. Pink, blue, purple, orange, green. Well, let's start off with pink. Pink. So there's pink. Nice pink racing stripe. B, 50. And so we're going to lay down a nice pink racing stripe down the middle. And then we can see that's on a layer. I simply hit save. When we come back to Unity, the texture has been updated. The material with that texture has been updated. The model in the scene has been updated faster than we can really see. Fancy color palette was just by clicking the colors section. It allows me to do pick a new color. And pink and blue. So blue. And then I'm going to add some, images down the side. Oh, let's do this on a new layer. Let's do this on a second new layer. And then I can just do this down here as well. And so now we've got, save this, and we can see that we now have little wingtip colors. And I can come back and I can change these layers, turn off one, and that's reflected in the update. I can, turn off the other. And so my layers are available. This is not available at runtime, but it's certainly available at edit time. So it's just nice to know that when you're doing your design phase, that you have your layers available. I'm just going to quickly make these even so that they're down along the edges. They're on our wingtips. Blue, pink, purple. So someone else will cried out purple. So let's quickly put in a purple layer. That's a good purple. Okay. Purple dot. It's not going to be perfectly square, all right, because we've got a slightly stretched image, but it gives us something amusing to do. So that's changing textures. So let's take a break. 2:15. Let's come back in 10 minutes. 2115. Let's come back at 2125, and we'll get on to setting up our basic game. All right, welcome back. So CJ, yes, you can change any of these attributes, any of these properties programmatically. Arguably, you could probably even write your own texture on the fly, but you have to get into get pixel and set pixels and that sort of stuff. Um, and again, it's like doing your mesh. You'd probably want to do it in Photoshop rather than try to do it in code. Um, come on, yeah, the icon thing. Um, Oddly, you can. Well, you can get small, but when you revert, those smallest icons and materials don't display. Not quite sure why that is. Probably an efficiency thing. Um, not quite sure, but what shader languages does Unity support? CGHLSL, and I believe GLSL as well. If I remember correctly, I can't remember off the top of my head because I know that you can convert HLSL into GLSL relatively quickly, and I believe that's what you need to do for specifically mobile shaders. Not something I've really done. And then, of course, Unity's own Shader Lab, and all of the Unity shaders, if I remember correctly, are wrapped in Shader Lab to be usable. Yes, you can deform a mesh. We can talk about that in Q&A. There's a game out right now that's in development that's just got a successful Kickstarter called Sons of Nor, and that's one of the shticks to that is that your Magic users can pick up the environment and break chunks off of the rock walls of the canyons, and they can take the sand and deform it so that the enemies fall into a pit. So yes, you can do that at runtime. So let's set up our basic game. Excuse me. So the very first thing we need to do is set up our build target. Currently, our build target is PC, Mac, and Linux standalone, and we want to change that to our web player. And that's because whenever we're working, Unity is optimizing. Just apply that, get rid of it. Unity is optimizing all of our assets for our build target. And well, the Unity editor and the build target. So we want to make sure that we have our current build target set, and we can do that by going to build settings, and we can set our build target. We're going to pick web player and do switch platform, and we now see that we have web player up here. The next thing we want to do is change our platform specific settings, which we can do by clicking the player settings button or going to edit project settings player. Now, since we're not building this, for distribution, say on the App Store, we don't have to worry about our company name or our product name. We won't see a default icon on the web, and we don't need to change our cursor. Again, we have per platform settings, and we will be working with the web. I want to change the resolution. I want it to be 400 by 600, so it's upright like those upright machines. I do not want it to run in the background, and I'll use the default white background. You can write your own web player templates if you want to. So if you're regularly writing installing your web player into a page, you can either write that by hand in HTML, or you can copy that and make that a web player template and simply build it out of Unity into that page, and you can just put that page up directly. The other settings, we don't need an icon, don't need a splash image, and these other settings, we're going to leave it default. Things like using DirectX 11, that sort of stuff. But this is all beyond what we're teaching today, so let's leave these all at default. So if we look at our game view now, if we stay in our web aspect, we can see that we're now in a portrait style game, sort of like those upright machines. Sorry, I'm reading Oblivion's. Will it affect it if I change the build settings later? You can change build settings later. That's perfectly fine. A lot of that is adding things. Like at this stage of the game, we wouldn't, if we wanted an icon, we wouldn't necessarily have to put it in. We could change our product name, that sort of thing. It's just best to have the settings so when we're building and testing our game that we have as many of these settings set up towards our final values as possible. So let's return to the editor and let's set up our basic game objects in our scene. So the basic game objects, let's start off with our main camera. So if we look at our scene view, we look at our main camera, we can do a frame selected. and then we can see that we're just in that default position where we're behind the origin point by 10 units, and we're up by 1 unit looking down on it. And I want to be down, looking down on the Y plane on our game view. So let's go ahead and reset the transform. So we're there at origin, and then let's just tilt down 90 degrees and then back off some. When looking at the main camera, there are a couple of basic settings, things like what's our background, skybox, solid color. Depth only is if we're using multiple cameras, which we're not using today. And don't clear is pretty much there if you're trying to do some funky effects, but aren't usually used in any game-related way. You essentially get a very smeary, overwritten look with don't clear. If we don't have a skybox, it'll default to solid color, even if we have skybox selected. But let's pick solid color for our background. And then let's go ahead and change our color to black, because I want to have a black background in my background. And there's no reason to have a skybox per se, because the skybox is 6 images, all of which need to be in our game. Our camera is always going to be looking down on the game board, so we'll do something with the background, but at this point, let's just have a little black background since we're out in the deep darkness of space. Now, when I'm looking, I've set my background to black, but I still see my spaceship. If I look at my hierarchy, I've got my main camera and my player ship. That's all I see in my scene view. So why can I see my ship at all? Well, that's something that you need to remember about. If we go to our render settings, we should be aware that every scene comes with a default value in ambient light. What is ambient light? Ambient light is just generally this light from everywhere and nowhere. You could try to light your scene with it. It's not particularly flattering. It's not a very nice looking light. It's primarily there with a small setting so that when you start putting game objects into your scene, if you haven't made any settings, you at least can see them in the game view. Most of the time, you want to remember to turn it off. If you've got a game where all the lights are off and it needs to be pitch black and suddenly you can still see your walls just a little bit, it's because there is this faint setting of ambient light in the render settings. Now, on the other hand, if you have a game where if everything gets turned off, you still want your player to be able to fumble around in the blackness and see something in the scene without actually having any lights, then maybe having a small setting setup or some value in ambient light might be good. When I started moving from motion control models into CG models, I found that ambient light to be very, very annoying and distracting because many people thought of it as fill light. But when you're filming a real model, you actually use a real light source, even for your fill light. And ambient light would take a really good looking model, nice gray sides, and make it look completely rubbish because you had no shape on your model, because there's no shape to this light. So let's set ours to nothing. And then we will come back to that when we set our lights in the scene. So the other settings that we have, actually, when I said let's get back to that, I meant to leave it up. Silly me. Render settings. Let's do that again. Let's get back to that when we put some lights in our scene. There we go. Because otherwise we can't, which is what it's for. It can't see anything. When it comes to setting our position of our camera, we have our choice of orthographic or perspective. And that's the difference between a camera that sees like our modern cameras are, our current cameras are, or our human eye, where things look bigger, look smaller farther away because our field of view gets bigger. Don't know what that was. That's strange. So now suddenly I see a lot of your comments, which I didn't see at all. So something funky was going on right after I got back. And then it crashed. So Adobe wasn't feeding me you at all, and I guess I wasn't feeding to you back again. What was the last thing you heard? I came back from break and I answered some questions, and then something messed up. All right, let me go back to where this was. Is that it? Are we done? Can't do any undo anymore. Let's set these back to some gray level. So did you hear about ambient light? Set this back to, let's reset this value. There we go. Yeah, I'm resetting up a bunch of things. You're going to get your screen in just a second. All right. So this is sort of back somewhere to where we were getting started. You heard about ambient lights. Yeah, and things, I don't know whether it was my system or Adobe Connect, but my pen, I thought it was my pen selecting things, but also my windows were going crazy at the same time. So I was blaming it on my pen, but something funky was happening, that's for sure. So we have our main camera, and we talked about if I set this to black, we can still see things. Why is that? It's because of ambient light. And then we started talking about, so we've got our skybox, we can set it to solid color. And then we'll change the color in a little bit. And then we talked about orthographic towards perspective. Let's bring this down, being something slightly smaller. And so we've got our parallel projection of the camera, which shows that no matter how close or how far we are from something, we have no perspective. And this is very good for doing sort of 2D style games because there is no perspective with them. So if you want to have no perspective, you make it an orthographic camera. You can also set your camera at an angle, and you can do isometric and orthographic games as well. You can set the size of the parallel projection. You can see it's changing both the front and the back at the same time. You can also change the near and far clipping planes. And to render anything in your game, it has to be inside this frustum. And so we've got the far clipping plane. Let's just bring this up. So we've got the far clipping plane. And so you have to be within the far clipping plane and within the near clipping plane. Otherwise, you simply just don't get rendered. You don't get seen. And if you think of some MMOs that you play where you're moving through the terrain, and if you look far in the distance, you suddenly see the hills coming out and being built, and the trees being built, and the castle on the hill being built, that's because those objects are entering the far clipping plane. Usually that's hidden behind fog, but not always. So if you're seeing your game world being built, you know, face by face, it's because that geometry is entering the clipping plane. If we have it in perspective again, the farther away we move something, the closer it is. We can see how it changes size in the value because it's smaller in the frame because the frame is defined by this frustum. But we're going to have an orthographic game, and then our camera we can set at the Y. We can simply set up, say, at about 20, and then let's just set that at 0 for now. And so there it is in the middle. So we could make our clipping plane 40 and put our game plane of 0, 0 there in the middle, somewhere in that. This is probably bigger than we need. I mean, if we wanted to, you could come up 10 and make this 20. Just big enough to put our game inside. And we don't have a big game going on. So there's our camera. And then we can set our background to black. And then we also want to set, as we can see that value in the game, we want to set our edit render settings. We want to set our ambient light to nothing as well. So now we've got nothing. We can't see a thing. So let's add some lights. Let's add a directional light. Remember our directional lights, they light the entire scene based on the rotation. So we can reset the transform. And there it is, looking in our game view at origin facing straight up. And then let's shine down on the scene about 30 degrees and then rotate it around. I don't really need to see the gizmo in the scene view. I'm looking at how the light's affecting my ship. So let's come from the front, but I don't want it to be purely right off the front. Let's just go off the edge a little bit, somewhere in there to 215. Let's just make it an even number. And then it's not very bright for me, so let's bring it up a little bit. Okay, that's nice and sharp. So there we've got a bright light there off the starboard bow. And let's now call this our main light. And then again, like we did in 101, let's duplicate this and call it our fill light. And then I want to drop this down a little bit so it's not as strong. And then let's swing it around to the other side, somewhere back there. I can look at that highlight till it's filling that backside. Let's even that out. And then let's give it just a slight different color. And if we look at our scene view, we can zoom in on our player, F for frame selected, and we can get an idea of what's going on. But again, look at that gizmo right there in the middle where my ship is. And it's too busy looking at the gizmo than looking at my ship. So let's create that new empty game object called lighting. Let's reset this to origin. And then let's grab the fill light. And the main light goes into lighting. And then I can just lift that up 100 units over the game board so it's up and out of the way, but still lighting our scene. And then I can look at that ship. So I can turn these on and off. So I can toggle on and off the fill light. That's giving me some nice fill to that backside. I can toggle on and off the main light, see what my fill is doing. If I want to, I could rake that a little less. Bring up that main light again. Cool. Anyway, so there we go. Fuss with lighting as much as we want to. Me and lighting spaceships. It's a bad habit. Put your hands up. Walk away from the spaceship. So we have our directional lights, and we have our new empty game object, so that we've got our hierarchy is beginning to take shape. And also, if you take a look at it, you can see that we've now got our project is in good shape. We can get a sense of how it looks, scenes and break images, models, materials, our lighting. There's our main camera, our main ship. We're starting to get a good sense of what we're doing. So the fill light is better than ambient light. Yeah, because ambient light just lights up everything. Remind me in Q&A, and we'll look at some things like Robot Lab with nothing but ambient light, and we'll see how terrible it looks. But it does have its uses. I mean, there are good reasons for it, and it does make a gentle fill. And some people do find good use for it, but I don't see any reason not to run a fill light in this case. It also gives us some nice shape on some of the other game objects later on in the game. And if you use a directional light, it's just as omniscient. It covers everything in the scene, just the way our ambient light would. So let's set up our player ship. So there's our player ship. And our player ship needs to participate in collisions. And so this means, in the very least, we need to add a collider. So let's close down some of these components, and let's add a physics collider. So let's add a capsule collider. We could have added a mesh collider. If we added a mesh collider, physics, mesh collider, but take a look at this, especially make that convex. Really nasty piece of work. It's automatic, it's covered it, it's done a web all the way around. We can calculate the inside volume. It's just not very efficient. So let's not use the mesh collider. Let's use a very simple collider, especially because we've got a very simple game going on. So let's take our shape, let's give it some height. Oops. And we can see we're on the wrong axis. So let's change that from the X, Y, Z axis, think along the Z. And then we can reduce the radius down a little bit. Let's make that to say 0.75. And then let's reduce its height until we've just comfortably grabbed around that, maybe say 225, somewhere in there. And now we've got a collision volume, especially considering we're on a plane, a little bit of invulnerability on the edge, but that'll do perfectly fine for what we're doing for today. And we've got a collision volume around it. Now, remember our discussion from yesterday about the physics system and collision volumes. And we look at, Unity's looking at the collision volumes of all of the colliders in the game, and that there's a difference between a static collider and a dynamic collider. Static colliders don't move. They represent the collision volumes for our geometry, for things that don't move in the game. And Unity will pre-calculate and cache all of the volumes of a static collider. And if we move a static collider, it will force Unity to recache all of that collider geometry. So since we are going to be picking up and moving our player ship, and it's going to be moving around, we don't want it to be part of the static geometry pool. We want it to be dynamic, and we do that by adding a physics rigid body. And this will tell Unity that anytime that this thing moves, it has a rigid body attached, so it's part of the dynamic world, and it won't recalculate and recache all of that geometry. Now, to be honest, in our game, I think everything's moving. There is no static geometry. So arguably, we don't need to do this on a certain level, but it is an incredibly bad habit to get into. So we definitely want to be able to move this, and we also don't want to move this with forces. We want to move this ship but just by grabbing its transform. This is an arcade game. We don't need to be using we're not doing the Kerbal space program where we want everything to be perfect Newtonian physics. So we're going to use is kinematic. So we're going to use a kinematic rigid body to tell Unity that this moving capsule collider is under our control and not part of the static geometry. So we want to start getting this object moving under our control. So we want to add a script. So let's create a new folder called scripts. And then let's take the player ship. Let's close down some of these components. Also realize that when we close down a component, the gizmo disappears. And then let's add a new script called player controller. And player controller is going to be done in C#. So create and add, and we now have player controller added. And when we do this, Unity will always dump these new scripts onto the root level, so we have to file that away, and then we can open that up in MonoDevelop. So remember our basic game loop. Unity reads all of the relevant code and all of the enabled components on all the active game objects and then renders a frame. So if there's anything we want to do it in either update or fixed update usually, because that's where our regular game code goes or our physics game code. And our script files are text files, and MonoDevelop is just a really powerful, very colorful text editor. So what do we want to do? Let's think for a second. We want to move the player ship. To do this, we need two things. We need to get player input, and we need to apply that input to move the player ship game object. So we want to check every frame for input, and we want to apply that input as movement every frame. We're going to use function update. Why not use fixed update? Well, we're not going to be applying forces to the player game object. And when we moved the ball yesterday, we were using rigid body add force. The rigid body is a physics component. Adding force is using physics, and so we would do that in fixed update. What we want to do is grab the transform, simply the position in space, and move that around in an arcade style. Now, second, we want to look. What do we want? We want input. And remember our little cheat sheet, which is that we have command plus single quote on the Mac, and then we have control plus single quote on Windows. So let me go ahead and put that up here. Let's cut that out, and let's just leave that at the top to remind us what we're doing. And so I can grab input, and then holding down the command key or the control key, and then single quote. And there is the input page. So input, we can see that it's the interface into the input system, and we use this class to read the axes set up in the input manager, which we are using today, and to access multi-touch and accelerometer data on mobile devices. To find out how to use the input manager, you read this section. To find out about mobile devices, you read this section, and you can follow the links to, input acceleration and touches and device orientation and acceleration events. And then we have our variables that hold values or references, and our functions that do something in our game, that actively do something, that grab those variables and manipulate them. So what we want to do, what we're going to be using today, is get axis and get button. Now get axis will return the virtual axis identified by axis name. And we give it a name, and it returns a float. But this is an interesting float. It isn't just any, float number. It is a value that's clamped between a range of -1 and 1 for keyboard and joystick input. Now, how do we get these? Well, these are set up in our input manager. So if we go to Edit, Project Settings, Input, we will see that this brings up the input manager. And the input manager is where we can set our default axes. There are 15 that are given to us already, and we're going to be using these default axes in our game. We're going to be using horizontal, vertical, and fire 1, but let's take a look at what these look like. So these axes are a way of associating buttons with an axis name that we then grab from the input manager. So we can see that we've set up horizontal here, and it is looking at the left button and the right button. And these are the left arrow key and the right arrow key, and that's the negative button and positive button. There's an alternative negative and an alternative positive button, A and D. If we look at vertical, very similar. It's got a name, vertical. That's how we access it. And it's looking at the down and up keys, the down and up arrow keys as negative and positive, and the S and W keys. So between the two of these, we have A, D, S, W, or the ASDW keys. And so we can use these to move forward, back, and left and right. What it means by it returns a value between -1 and 1 is that if we're holding down no button, we get 0. If we're holding down a negative button, we have a number that moves towards -1. If we have the positive button held down, it moves towards 1. So as we hold down our buttons, it's moving back and forth between 1 and -1, and we use this as our base movement, where holding down the button, which basically gets to 100%, or the joystick cranked all the way over, is 1 or -1, and then we can multiply that by some value to get the speed of our character. But let's take a look at this. We can see it's listed twice. Now we've got another horizontal and another vertical. What's up with this? Well, these are mapped to joystick axes rather than key and mouse buttons. This means by simply polling horizontal, we can find out if there's input from the joystick, we can find out if there's input from our controller, we can find out if there's input from our keyboard, but we don't care which one. We just want to know, is the horizontal axis being activated? Is somebody holding down a controller? Is somebody pushing the joystick? Is somebody holding down an ASDW or arrow key? And we can do this by name. If we're looking at an input get button, we only need to worry about the positive button. Input get button doesn't return a float, it returns a Boolean value. True, false, on, off. Is the button being held down? Yes or no. And we can use these for jump, we can use these for fire. So we set these up in our input manager, and then we access them in our codes. So let's go ahead and write some code. What we want to say is we want to create a variable to hold the value that comes in from input. So we create a float variable called, let's say, move horizontal. And it's going to be equal to the input get axis and that axis is going to be horizontal. This has to be typed correctly because we're looking at doing a string lookup. So if you're worried, you can also copy and paste this. And then we want to create another float variable called move vertical, and it's equal to our input get axis vertical. And capitalization is also case sensitive. It's more complicated when you're specifically looking at the gamepad. Gamepads, I'm just beginning to get my head around because there's so many different possible inputs and different ways of dealing with them. And so I can't fully answer GameCat. I've got two. I just haven't set them up. I've got both an Xbox and a Nintendo controller here, and I haven't used them. I haven't got them hooked up yet because I just haven't time. And we can look up different ways of doing that, but you can hook up your controllers through that. Primarily, the ones that are really easily built in are joysticks and keyboards and mice. So we now grab our input. This grabs our input from our move horizontal or move vertical equals this value from our get axis horizontal. So it's going to give us a -1 if we're holding down the negative button, 0 if we're holding down nothing, +1 if we're holding down the positive button. So then how are we going to move our player's ship? Well, we want to move it by grabbing the transform, preferably in the X and Z values. Oh, I haven't finished. I've jumped a step. Sorry, guys. We'll get to that in a second. I realize I haven't finished setting up my camera. Rushing ahead. Sorry about that. So we've got our player, and we need to move it. Well, we're moving our transform, our player's transform. So let's look at transform. Now, we've clicked on this, and we have the transform component. Yeah, I mean, they're not defaults. There are ways that you can set up analog sticks, but it's beyond what we're doing today, and it isn't something that I've actually done, but I want to. But yeah, it's doable, and you can set up controllers. You can set up gamepads, and you can get your game to work with them, but it's not necessarily trivial and out of the box. No, that's okay. So if we're looking at the transform, this is the component, but this is not really what we want. We don't want the component reference. We want the scripting reference. So remember, we can switch to scripting, and we have our transform. Functions do things, so let's look down, and the very first one is transform translate. It moves the transform in the direction and distance of translation. Once we've read the description, we click on the link, and there is the link, function transform translate. And the signature tells us that we need a vector 3 for translation and an optional relative to value, which describes how we're going to use that vector 3. If relative to is left out or set to space self, the movement is applied relative to the transform's local axes. If relative to space world is set, the movement is applied relative to the world coordinate system. And what we're essentially saying here, in our game, our local transform is actually in line with the world coordinate system. So it's not going to make a really big difference. But let's pretend it did. So we have a different location. If we now move in space self, that's forward in space self. Or if we do nothing, just say move forward. That's transform at vector 3 forward. Or 0, 0, 1 along the z-axis. We can see it's not aligned with the world z-axis. If we were to move in global space, which is to leave, to say space world, that's vector 3 forward. So we can move this, we can translate this object in global space or local space. The advantage of local space is every frame, you can pick a new rotation, say you're maneuvering, and forward will still always be along your nose. No matter what orientation you have, that will still be your local transform forward. So we're going to reset this. Frame selected. There we go. So what do we want to do? We want to do a transform translate and then a vector 3 and then a space. Let's use space world since our game is so set to this this limited space with our XZ plane. Let's move it in space world so we always know that we're there along that plane. So what we want to write in our code is we want to do a transform, and that grabs the local transform with a lowercase t. We want to use the function translate, and that needs a vector3 and space world. Oops, come on, you should have done that. Space and then world. But how do I get my float values here into that vector3? Well, let's think of our vector3s. If our vector3 is made up of an x, a y, excuse me, an x, a y, and a z. Oh, thanks, code completion. Then we can start to break this down. Our vector3 is made out of an x, y, and z. So where do we want to move? Let's start something simply. Where do we want to move on the y? We don't want to move on the y at all. We want to stay on that xz plane. So that's going to be 0. Plainly 0. Where do we want to move on the x? Let's move horizontal. That's our left and right keys. And where do we want to move on the z? That's our move vertical, or our up and down keys. So now all we need to do is make a vector3 variable. Let's call it movement. That's equal to a new vector3 that is horizontal, 0, and vertical. And then we simply need to move movement. Yep. And Unity likes that. Now, we need some control over this. Remember what we did before, where we had our public float called speed? So this allows us to multiply our movement. So we can simply multiply all of this vector3 movement by speed, and then also by our time.delta time. We know what time.delta time is. That's the time it took to render the last frame, and it makes our game frame rate independent. So let's save this. Let's come back to Unity, and let's fix our camera, because I forgot to position the camera. So if we go back to the game view, our camera is in the wrong position. Let's reset this. So we have our ship is lined up, and our camera is also lined up there on 0 as well. Now, to have a good starting place for the ship, we want it down here somewhere. But I like the fact that my game starts with the player at origin. All things are relative. If I can't move my player ship, let's just move my camera in the other direction. So I don't know. Let's just say 10 units. So that's a good starting place for our ship down there. So now we've written our code. Input get axis horizontal, input axis get axis vertical. We then apply that to movement, and then we do transform, translate, movement. Let's hit save and let's hit play. Hold down the arrow keys. Oh, and let's give ourselves some movement value. Silly me. 10. So we need a value. We're speed of 0. We're not going to go anywhere. 1 times 0 is nothing. So we hit play. Hold down the arrow keys, and now we can move around. There we go. So if I'm holding down the up arrow or the back arrow, I'm getting input get axis vertical, input get axis horizontal. And between the two, you can hold down 2 keys at once and go diagonally. We have a problem with this code. And that means we can keep on moving forever. And we have no idea where our player has got to. And we need to find some way that the player can get constrained inside our game board. Now, there are a couple of ways we could do this. We could put blocks around the outside of the game field. And we could say, let the player ship bump into it and not go anywhere. But I think it's more elegant to do this inside code. All of our code is called in order, one line at a time, and at the end, we render our frame. So if we've moved using this line, transform, translate, movement, if that takes us outside the game area, we can bring the player back into the game area. And this also gives me a chance to show off something called mathf. One of those things you won't know about unless someone tells you about. Mathf is a collection of common math functions. It has things like move towards. Move towards is really great. You have your current value, a target value, and the speed at which you change. Why would you use this? My current health, 50%. My current target, 100% health. 2,562 hit points. I've got 1,512, and my heal rate is my max delta. So you can use this to move any value towards another value. Think about it if you want to bring back your health points. They've got class variables, pi, infinity, epsilon, and class functions, sine, cosine, tangent, power, log, ceiling to int, floor, lerp. You can linearly interpolate between two values or between an angle. You can do damp, ping pong between two numbers, repeat, Perlin noise. You can generate random 2D Perlin noise. And then also clamp. Clamp is great, works for both int and float. You can give it a value, and a minimum value and a maximum value, and you'll be clamped in between those two. So what we can do is say, after we've moved, that our transform position, where we are in space, is equal to a new vector 3. And remember, again, break these down. What is our vector 3 made up of? An x, a y, and a z. And we need to clamp these. Now, this particular line is going to get a little long. So like a function, I'm going to break this down a little bit so that we can see each line. Even though this is sort of one line of code, I'm breaking this into little bits. Where's y? Our new transform position is going to be equal to, our transform position will be equal to a new vector 3. And, well, if anything moves us off that y value, we'll definitely pull ourselves back. We want to move nowhere on the y value. We want to stay at that 0 level. And our x, it's going to be mathf.clamp. And what do we clamp? We give it an x value and then a min and a max. So we give it our transform position x. And then we want to give it something called x min, which we will write, and then x max. So we want to say, if we're between the left and right side of the game board, we clamp it. Same with z. We can simply copy this, paste this in for z, and we don't want to have that comma, and then change these values to a z. So what we're saying is our new transform position is going to be our current transform position clamped by the game board. So we need to make some variables for this. We can make a public float called xmin, a public float called xmax, semicolon please, and a public float called zmin, and a public float called zmax. Let's come back to Unity, and when we come back to Unity, we'll see, hey, we've got some more values to fill out. So how do we set these? Let's just grab our player ship and move it around. Oh, the player ship. Did I move the camera? Oh, I moved the player ship. Silly me. That should be at 0. This should be at 10. Done. Sorry about that. Because I want my player ship at origin. So I can grab it on the X value and move it over to the edge. Oh, There is something wrong with my pen there. Bink. So what is that? That's a bad value. Let's make... I'm really not doing very good today, am I? Missed a couple of things, all with this silly camera. I didn't set the orthographic size either. I'm sorry, because of that getting distracted, I pushed through that. And so this should be, if you're following along, 0, 10, 10. And then this should be at about 15. So I just never set that size. I left that roughly. So this means our player ship is there at origin as its starting point. And I know this because I do this enough times that the player ship, when we look at the edge of the game board, is usually at about 9, minus 9. So it needs to be between 9 and minus 9. And so those are our x min value, and our x max value is going to be minus 9 and 9. And the z min and z max are the same sort of way. Z min, just down along the bottom, we could get pedantic and say minus 4 and a change, but I think, whoops, 4.0, that looks close enough. And then the z max, we also need to give our players, our enemies, a chance to spawn. So maybe 12, somewhere in there, so that we stuck down here at the bottom, gives our enemies a chance to spawn up here, and maxes out at about here. So then we're talking about minus 4 for our z min and 12 for our max. So now with this, we're now clamped. So we move the ship. If we're out of bounds, we will then be clamped back into it. Hit play, hold down the W key or the up arrow, and we stop exactly at 12. Right arrow, we stop at minus 9. Or left arrow, right arrow, we stop at 9. Negative, minus 4. And every frame, we will continue to move out of bounds and be brought back in. Oh dear. So you're saying this is why. That's okay. You just need to translate the way things are working in your vector 3s. Because we're not dealing with gravity, you're simply playing your game here. So what do you have? The camera looking down the Z value? And then your game is playing on the XY plane? That's perfectly fine. You can quickly change it. Also, I did forget to distribute this last time, so I'll distribute this at the next break. So you can change that. You can quickly change those around very quickly by taking your main camera and just setting it to 0, 10, 10, 90, and your player ship should be at, oops, let's stop playing, please. Your player ship should be at origin. So just set the player ship at origin and your main camera at 10, 10, 0. And this is, player ship has no rotation either. The only thing that might be a bit funky is you may need to change your lights around, but see how that looks. No, unfortunately, you can't change the orientation of this or, where is that? The grid. So let's shoot some shots. Let's understand the process of shooting shots. When we grab a button, when we click a button, when we click a button, we want to create a shot in the game. We will be grabbing an asset from our project view and we'll be making an instance of it inside our game world. Spawn it. Therefore, we need to create a game object to shoot, and we need to save this game object as a prefab asset. And this game object that we create needs to be self-motivated. It needs to move immediately when created in a sort of fire and forget kind of way. We will make one working game object and save it as a prefab, which we can access from the scene by having a reference to it in our code. Now remember what a prefab is. It's an asset that contains a template or blueprint of a game object or game object family. And when we create that prefab from an existing game object, we can, once created, we can use this prefab in any scene in our current project. So let's create a shot that we're going to shoot. So I'm going to do this in the game view. just so we can see what it looks like. I'm also going to turn off my player ship. And we're going to do this with a particle system. Again, I'm not going to go into the great details of particle systems, but look over my shoulder and you'll get a hint. So let's reset that value so that we don't have anything funky in the transform. And then I want to make sure that I have looping in prewarm. Prewarm will give me one full set of spawned particles on the very first frame. I want my lifetime to be short. I want my speed to be 0. I'm going to move the object using its transform rather than moving them as particles. And I want my size to be between two values, small and small-ish. I want to start color. If I start color, I want between two colors. So it's going to be randomly between yellow and red. So with orange in between. And then I want to change the shape from a cone to a sphere, and then reduce that sphere radius to its minimum size. So essentially, they're all piled on top of each other. So we can see now we've got an interesting visual effect that we can use in our game. So let's go ahead and look in the scene view, and then we can frame selected, and zoom in on that. And this is just simply a visual effect. It doesn't have anything that does anything. It just looks pretty. So we need something with some oomph behind it that actually does something, and that's going to be our physics sphere collider. Now our collider will be able to bump into things, and this is going to be what's doing the work. Also, remember, we're going to be grabbing this particle system. Let's call it shot. And then we're going to be moving it by its transform in the scene. So we need to remind our game that we are dynamic. So we're going to use a kinematic rigid body on our system. And that's our shot. So let's create a new folder called prefabs. Keep our project organized and drag that shot into our prefabs folder. And then I can delete the instance out of my game and then come back to my game, and I can turn my player. I'll leave my player off for now. Kinematic means that the rigid body object is, we're saying that it's part of to a degree, part of the physics world. It's a dynamic object. We can move that collider from frame to frame without triggering the static collision being, the static colliders all being recached and recalculated. But at the same time, by checking out it is kinematic, it's not participating in forces. So it doesn't have, it doesn't use gravity. You can't do an add force to it. If you do an explosion next to it, nothing will happen. And you can move it by changing its transform. If it isn't kinematic, you have to move it using forces, and you then have to be pushing it around in update, a fixed update using forces. The other advantage is that when you want to do something that you're animating or you're using programmatically with moving the transform, and you want it to react with physics, like an elevator, you would be moving it in fixed update. You'd be moving it by its transform, but you'd still be leaving that as is kinematic. So now we need to control this shot. We need to have it move in our game. And we can now work directly on the asset. So let's add a new script, and let's call this shot controller. And let's put that into our scripts file, and then let's go ahead and open that up. And here's our shot controller script. Now, what do we want it to do? We want this to move up the game board. And we want to do that by moving its transform. Where have we seen that before? Transform, translate. So we can copy that into our shot controller and simply paste. Transform, translate movement. space world. Well, we don't have anything set up for movement. So we remember what we wanted to do. We wanted to move up the X or up the Z, which is basically moving along the Z value. And Z is vector 3 forward, 0, 0, 1. So that simply moves up the game board. Very simple way of moving up the game board. We also need speed and time dot delta time, so that we have control over how fast this moves, and we're frame rate independent, and we do that in space world. So let's get rid of all of this extra code and type in our public float value called speed. And that's all we have. Very simple movement script there. So we can look at our shot. We've got our shot controller, our speed. How fast was our player moving? 10. So let's move 20, 25, just faster than our ship. Let's hit save. Let's come back to our game view, and we can practice this by just dropping the shot on the scene and seeing what happens. All right. So these instances, the moment they're dropped into the scene, they just take on off. They tear on up the game board in the direction that our enemy is coming from. So that's what we want to have happen. So remember, transform translate moves our object by the transform. Time.delta time is frame rate independent, and vector 3 is our position or direction in 3D space. So now we actually have to shoot the shot. So let's think through this process again. We need a reference to our shot prefab. So we need some way to reference that. We need a location in the game world to spawn it. We need some place in this game world to say, hey, this is where we're going to create this new shot. We need to limit how fast we can fire. And we also need the code that actually does the instantiation. And we want to do this when we click a button, when we click the fire button. So let's look at input get button. So input get button, when we call that button name by name, we're given this Boolean true or false. And conveniently, this entire code snippet in JavaScript, C#, and Boo is all about firing a shot. And you can see they've done the same thing we were talking about. They have a public game object reference to a projectile. They have a fire rate, how fast you can fire. A private float, which is limiting how fast we can fire. And then we have the code that actually does this. And the way that it limits the fire, you can see there's this relatively complex if statement. Normally, if A is greater than B, or if I'm holding down a button. But take a look at this. If input get button fire 1, that makes sense, and time.time is greater than next fire. So you can use in an if statement, you can use 2 ampersands to mean and, or 2 pipes or 2 upright lines to say or, and make a complicated if statement. Right now, this will only prove true if we're holding down the fire button and time in the game is greater than our next fire value. So the way this works, let's step through this if we're playing our game. So game starts with 0 at time. The time in our game is 0, and I don't hold down a single button until 1 second in the game. At 1 second in the game, I hold down my fire button. So every frame up to that, we're reading this if statement. Is the fire button being held down? No. So it's ignored. Is the fire button being held down? Nope. It's ignored again. At 1 second into the game, I hold down the fire button. Is the fire button being held down? Yes. Okay. And time.time of 1 second is greater than next fire of 0. So we execute the code. Very first thing we do when we execute the code is we set this next fire rate to be equal to time.time of 1 second plus the fire rate of 0.5. So now next fire is equal to 1.5. Then we come back here. We create our shot in the game. But let's say I continue to hold down that fire button, because I can hold it down as long as I want to, and it'll be all like auto fire. And then the next round, let's say it's 1.1 seconds into the game, I'm holding down the fire button. Good. We keep evaluating, and time.time of 1.1 is not greater than our next fire rate, which is reset to 1.5. So then we don't execute this code. And this doesn't happen until time.time is greater than 1.5, and we do it all over again. So that's how we're limiting our fire rate. And then this line here is what instantiates our projectile in the scene. So let's take a look at instantiate. Instantiate takes an object, a position as a vector 3, and a rotation as a quaternion. How many people out there actually know what a quaternion is? I can say I barely understand what a quaternion is. Well, conveniently, we've got a little button. It takes us to it. It's a fourth dimensional representation of a rotation. Oh, crackers. Made up of X, Y, Z, and W. Note that they say, please don't touch these unless you know quaternions inside and out, which I don't. They're compact, they don't suffer from gimbal lock, and they are easily interpolated, and Unity uses quaternions to represent all rotations. Exactly. Now, luckily, my fourth dimensional maths are not really that great, but luckily, the quaternion functions that you use 99% of the time are these: look, rotation, quaternion angle, quaternion Euler, which returns the X, Y, and Z, slurp, rotation, and identity. So when we're looking at this, that looks like, sorry, the rotation that looks like an X, Y, and Z, we're looking at what's called the Euler angles of a quaternion. Now, I don't really want to read in this class. There's a lot of stuff going on. If we have to, we'll get to it later. But there is one place. Yes, gimbal lock. There is one place where we can find in one compact little package, a vector 3 as a position and a quaternion as a rotation. And that is in a new empty game object. All game objects come with a transform. All game object transforms have a position and a rotation and a scale as a vector 3 and a quaternion. And so I can use this game object as a spawn point. And I can pass that spawn point. Let's put that into our player ship, and let's bring our player ship back. I can pass that spawn point as a reference and use the position and rotation as a vector 3 and a quaternion. So I can go ahead and grab this spawn point, and I can stick it out in front of my ship somewhere there. Let's just make that even. And also as a child object, wherever I move the player's ship, that spawn point is going to go. Everywhere that Mary went, she had a spawn point, not a little m. And so I now have a convenient place, almost like a hard mount for my gun, that wherever I move my ship, I can say, look at that position, look at that rotation, and that's where I want to spawn my thing. So let's go ahead and reset the transform of our player ship and come back to our get button, because now I have a position and a rotation. So let's write some code. We're going to need in our player controller a reference to our shot. So it's a public game object reference called shot. And then I can have a public game object reference to my shot spawn. But if I did this, then I would need to get my shot spawn.transform .rotation, etc. And that's an extra line. I can ask Unity for a transform. And when I put the game object on it, I will find the shot spawn's transform. So I can simply say shot spawn.rotation. etc. So I've got my shot, I've got my spawn. I want a public float for my fire rate. And then I want a private float for my next fire value. And I want to set this in awake. I want to set next fire to 0. Now the rest of this I can pretty much lift directly from this code snippet. So let's just lift this up, take it in, and then at the bottom of my function update, let's just drop that in. And then I'm also going to correct my indents, make sure that they are tabs. And so now let's just make sure I've got all this right. If input get button fire 1, that is correct, and time.time is greater than next fire, okay, then my next fire equals time.time plus fire rate, that's correct. And then game object clone, we want to instantiate our shot at our shot spawn position and our shot spawn rotation, and then I want to remove the typo that gives us as game object twice. That's a typo. Unfortunately, it's generated by the auto code generators for some reasons I will not get into at this point, so it always comes back. Why are we grabbing the game object clone? It's a rather interesting bit of philosophy. How does next fire variable get incremented? It gets incremented here. So every time this is true and is successful, then we increment next fire to be equal the current time we just fired plus our fire rate, which means that this will not be able to prove true until we've weighted the time of fire rate. Averon, habit. I like to see the declarations here and then the initializations in the game, but there's no major reason for not doing it here, except that I sort of want to show that you can do this in Wake. You actually could arguably do it in Start as well. The biggest difference is, and we talked about this I think yesterday, is that if you initialize here rather than here, you're given a default value. If this was public, you give a default value in the inspector. If you do it in Awake, you will always override any value that you set up in the declaration or in the inspector. It's mostly style. There's a lot of coding style. I mean, do you drop your brace or not? Some people like to have these things very short, move horizontal. Other people like to have them verbose. I write them generally more verbose in these classes just so that you can read later on. You get lost, you get see something and you don't see MV and wonder whether that's motor vehicle or mum's vase or move vertical. But usually on my own code, I'm not quite so verbose. Style. And be aware that you should work the way you want to. There are some differences, but whether you declare it at the time or in Awake, there's really not very much. So why do we grab a clone? Time.time is the time in the game. It's the time since the game started, but affected by changing your time scale, because you can slow down and speed up time, and it'll affect time.time. If you look at time, we can talk about this more in Q&A, but you can see there's time scale, which is how fast the time is passing. You can use it for slow motion effects. You can set it to 0 and stop your game, but you have to be careful with how you do it, because you can sometimes stop the button that will allow you to start it back up again if you're not careful. Time is the time since game has started in seconds, but it's affected by time scale. And then there's real time since startup, which is not affected by time, scale. But definitely, it's all part of the time class. And remember that if you're curious about any of this, rather than researching the whole thing, command single quote, often it's fun to look at the class that it's coming from, and you can see all of its brothers and sister variables to give you some context. So we grab a clone because if you don't have a reference to something, sometimes it's a real difficult chore to get one. 6 Degrees of Separation comes to mind. I want to see a good movie. Want to see Will Smith actually act? It's not a bad movie, 6 Degrees of Separation. But the idea is that if you've got a reference to something, you have someone's telephone number, you have someone's address, you know where they work, relatively easy to track them down and do something with them or to them or invite them out to dinner or whatever. If you don't, if we just instantiate shots in our game and we have no reference to them, and then later we want to find that thing and do something to it, it's very hard to do because you have to find some difference. If I want one specific shot, and there's 100 shots, but they're all generic game objects, and how do you find it by name, by type? It's not easy. So when you instantiate something, you optionally get a reference to it that you can choose to grab. And if you choose to grab it, you can then do stuff with it. You can stick it in a list. You can give it a name. You could say, clone.name equals, new shot space, plus, speaking of time.time, and you got a timestamp, so with a unique number on it, whatever. So you can do something with that specific object. You can put it into a pool. You can put it into a list. On the other hand, if you don't care what happens to this object and you will never, ever need to do anything with it, don't bother grabbing that reference. You can just simply instantiate this generic object. And if you do that, you don't need the cast, which essentially this is a generic object, and Unity needs to know what type of an object it is. So we're saying this object is a game object, and save a game object reference. In our case, we're going to simply just fire and forget and not have to worry about it. So let's save this and let's come back to Unity and take a look at our ship. And we can see that we now have a reference to our shot. We have a reference to our shot spawn. And we have a fire rate, which makes a 4 times a second. So let's save this. Let's hit play. And now we can shoot a shot. And since our shot spawn is attached to our player's ship, we can move around the game board and we can shoot as many of these as we want. Now, we do have a long list of clones. How do we get rid of them? Exactly, we should destroy them. They start taking up space. They're being processed. They're continuing to go up the game board, so they're being processed as well. But I don't want to just get rid of this by time and have them last 2 seconds and have them blow up or something like that. Because the farther away you are down the game board, the longer it'll take to travel. I want them to be destroyed when they leave the game board. Well, I can do this with code as well. If I look at my shot controller, I can create a new public float called Xmax. And I can say, after I move, I can say if my transform position Z is greater than Xmax. That should be Z max, actually. That's going up the Z axis, isn't it? Let's make that Z max. Then if it's greater than Z max, I can simply destroy that game object. So I move every frame, and every frame I check, have I left the game board, yes or no? If I've left the game board, pow, I destroy the game object. Now with that, I need to give it a value. Let's take a look at our shot. We now have a Z max. So let's drop one in the scene and let's pop it up. Same basic idea. What's 25? Well, we say greater than Z max, it's going to travel off the board the next frame. We could be, say, 26 if we really wanted to. So 25, 26, I think all of that's not going to make much of a difference. Make that change to the asset, not the instance. Save, play, fire. And now as they leave the game board, boop, they're gone. So let's take a break. A little shorter one. Let's make this an 8-minute break just because I feel like we're running a tiny bit behind. So now a 7-minute break. So let's break. And let's say back at 22:50 if we can. Oh, no, I lied. Let's make it 22:55. We've got enough time. We'll do it. 22:55. Make an even number. Take a 10-minute break. Plus a little bit. Back at 22:55. And hopefully when we come back, we won't have that same kerfuffle. All right, welcome back. Yes, when it comes to mesh colliders, you can create any mesh you want. Show them around. One of the things that's not a bad idea is to make a simplified mesh. So if you've got a mesh model, as opposed to letting Unity use your model for a mesh or to use something complicated, make a simplified collider. If you've got a very, exotic looking, I don't know, fountain, there is a teleport device that's in the robot lab, and all you need is a simple, cylinder around some parts of it to just keep people from pushing through that geometry. You don't need all of the detailed geometry. We could probably make a very simplified mesh for our player ship that was even wedge shape and triangular. These 2 points probably create 1 point here and 1 point here, and find some way to cage it, and you'd have a relatively simple volume to worry with, rather than a very complicated one that you're letting Unity deal with. They're both the same. C# and JavaScript are pretty much the same. It's a question of style and taste, whether you want to deal with a strictly typed language or a dynamic language. But ultimately, if you write the same code in both languages, you'll have very similar performance. Yeah, what you'd want to do is you'd have to bring that mesh in as a separate mesh. You don't want to, and then apply that mesh as you want to create a separate mesh, import that mesh and just call it like ship collider, wall collider. In the case of a wall, I probably would just use Unity's box collider and stretch it because it's built in. But if you wanted to do something that was slightly more complicated, I'd make a simplified collision mesh, import that as a mesh, put it into a different import, instead of models, create models, subsection, collision meshes, and then apply that mesh to the model you want it to be attached to. So let's talk about making enemies. So making an enemy, relatively easy. We're going to create a cube. We're going to reset it to origin. We're going to move it out on the Z to about 12, rotate it over 45 degrees in all 3 Euler angles, and then we call it enemy. We're done. We have an enemy. Yes, you can ask about that type of stuff in Q&A. Would be perfect. So we've got this enemy now. I'm going to quickly add that same script that we wrote yesterday called rotator, because I want to give our enemy a little bit of life. And I'm not going to go into the details of this since we covered that yesterday. And I just want to give our players something interesting to look at for our enemy. And it's simply going to be transform, rotate, and then we want a new vector 3. And our new vector 3 is going to be 15, 30, and 45. And we're going to multiply that by time, dot delta time. And we're done. We can get rid of all of this. Oops, not that, but that garbage we can get rid of. Save this. Come back to Unity and hit play. And we should see our little guy rotating around. And partly it's also a good example. Notice how we can always see the 3 forward facings on the cube, and they're all slightly different. That's because we have that fill light. If we didn't have that fill light, you can see what would happen. And that's partly why we have a fill light in there and make it that different color. Subtle, but it helps. So we now have our enemy. Now that we have our enemy, we need to figure out how to destroy our enemy. And so part of destroying the enemy is registering that collision. We have a box collider built in. We need to move our enemy. So again, we're going to need that physics rigid body marked as his kinematic. And so let's go ahead and move that up. And then let's move this down. And let's move our mesh renderer up as well, generally keeping our components together. So there's our cube, our mesh renderer, rigid body, box collider. And we've got our rigid body marked as is kinematic. Yes, we're going to have moving targets. Not terribly difficultly moving targets, but they will be moving. So our current shot only travels up the screen and has no destruction logic. There are many ways that we can figure out how to destroy this enemy that we have. And so I want to have the enemy object handle all the destruction behavior. There are a couple of reasons to do this. One is that it's good to show how to handle the logic of interacting between other game objects, but also I feel that the enemy is the driving force. We'd only need to have one, in this game, simple as it is, we only need to have one place to have our destruction logic, the enemy itself, because the enemy will destroy our shots when it runs into them, and our enemy will destroy the player when it runs into it. And then our enemy will also destroy itself. You can leave gravity on because once you've set this as kinematic, this object will not receive forces. And gravity is a force. So if you really wanted to be pedantic, you could turn that off. But by simply clicking as kinematic, you're also turning off use gravity, because gravity is a force and kinematic means there are no forces involved on this object. It's like gluing and stapling if you wanted to do that. So if you do this, I mean, let's take a look. Let's take a look at our rigid body. So we've got our cube here. If we have use gravity on and it's not kinematic, you hit save, you hit play. We've got an orthographic camera. So let's see this in the scene view. So we hit save, we hit play, and we've got the game popping up. Let's hide the game down here. We hit play, and we can watch the cube drop into the void. We can leave this as a non-kinematic object, as a proper force-driven rigid body object, turn off gravity, and now we're not using gravity. It's not falling, but it's still force-driven. You could use this in fixed update. You could add forces to it. You could add explosion force to it. A normal rigid body. So like if you want to have a physics-based game where there was no gravity, you can just turn off use gravity. On the other hand, if we have is kinematic clicked and use gravity is on, it's not affected by gravity because it's a force. So what is our goal? How do we have the enemy destroy all of these game objects? Well, we want to have the enemy destroy everything it touches. We want it to destroy the shots. We want it to destroy our player. And we want it to, when it comes into contact with something else, also destroy itself. Our goal is to listen for or detect the event of contact between two objects. And then additionally, we will need to test these objects to see if they're correct. We want to use this event to initiate new behavior, and we want our collisions to be this event that does the initiation, that initiates this new behavior. So we're going to need a script. So let's add a new script. Let's add this as enemy controller. And it's an enemy controller script. So let's go ahead and put that in our scripts folder, and let's go ahead and open it up. Now, before we look at what to write here, let's come back and look at our enemy, look at our box collider, and then let's look at that component page. The main reason for looking at this component page, it talks about all of the details of this collider, is the collision action matrix. This is at the bottom of all pages on the colliders. And we can see that there are collision detection occurs and messages are sent upon collision when these matrices stack up. So a rigid body collider, when it bumps into a static collider, another rigid body collider, or a kinematic rigid body collider, will send a collision message. But all of our kinematic rigid body colliders right now is what we have in the game only collide with rigid body colliders, and they do not collide with themselves. The only place that we see regular collisions with kinematic rigid bodies are rigid body trigger colliders, and they collide with everything. So we can't use collisions, we have to use triggers. So what we need to do is make sure that our box collider is set to its trigger. We could be pedantic and also set the collider states on the player and the shot, but currently only our enemy is going to be doing the code, so only our enemy needs to be set is trigger. So let's swap to our component reference, from our component reference to our scripting reference, and then we look down and we find, let's get that a little bit more front and center, messages sent on trigger enter. And this is the same message function that we used yesterday in 101. Void on trigger enter, we've got our collider called other, and we want to destroy the other game object. In this case, we are going to use this code straight out of the box, and let's go ahead and just stick this in here instead. And let's fix our indents. Void on trigger enter, collider other. We destroy the other game object, and then we destroy ourselves. Now, we could do this the other way around, because this destruction happens at the end of the frame. Unity will just tot up everyone who's supposed to be destroyed, and at the end of this frame, run through all the destruction behavior. So it doesn't make a difference which order we run these in, but gosh, it seems silly for the enemy to destroy itself before destroying the other game object. So this makes me feel more comfortable. So let's swap back to Unity. Let's save this. Let's come back to Unity, and let's test. Let's learn how to speak. Boom, gone. So anticlimactic, let's do it again. So there's our enemy, we're in play mode, shoot, and we blow up. Now we need explosions. Can we define target points? Yeah, you'd need multiple colliders, one for each one. You have to put a collider around the head, a collider around the arms. In each would be detecting that hit, unless you got into complicated hit testing in some other location. But at the same time, this makes sense, because if you've got an animated character, all of those bits are moving, and these are rigid body colliders, so you're not talking about deforming your mesh collider. So I'd assume you'd have a cube or a capsule around the arm, around the forearm, the upper arm, the lower arm, the hands. You'd have multiple colliders that would be testing and receiving those hits, and you could find out which one you were touching. So we could make our particles with Shuriken. You and I can sit here, have fun, next hour or two, into the night, making particles together. I'm sure it would be fun. But on the other hand, anything that gets in the way of shipping a game is not necessarily a good idea. I like playing games. One thing I like better than playing games is making games. And the one thing I like better than making games is shipping them and watching them disappear in my rearview mirror off to congregate the App Store, Google Play, so they can make me some money. So especially at this point, where we're working out the rough terms of our game and gameplay, we're using potentially stand-in objects, which we could later replace. Let's not reinvent the wheel. Let's see if somebody else has done that for us. So we can go to Window, Asset Store, or Command or Control 9, and bring up the Asset Store. And remember, the Asset Store is where we distribute assets. We can do models and textures and sounds, complete projects, animations, particle systems. Hey, how about particle systems? Now, I'm cheap. I'm a cheap old man. Let's sort by price. Let's look for something free. How about that? At one point, I was the only free particle effect. I thought that was really funny, is that you go into these other sections and you get piles and piles of free things, but not particle effects. Everyone wanted at least $1. Simple particle pack. So you read the description, you look at the ratings. I'm only getting 4 out of 5. And then you decide if this is good, you import it into your project. I said import it into a project. Thank you. Now, there's this particular package seems to have included some asset store assets, which shouldn't have been in there. I need to fix that, so I'm turning those off. But pretend that those weren't accidentally included, and I can just simply hit import. And you can see that we unpacked and imported that pack into my game. We can also, it's better if we're in 2-column mode than single-column mode, but we can also search the asset store for particles. And if we look, there's a little pull down here. We're looking at our assets, or we can look on the asset store, and we can see these same groups of particles. There's everything with the word particle in it. Just a pretty nasty view. We will eventually find mine in there in the free assets, looking for a better view. So we can also search without ever going to the asset store. If you really need something, let's just go to wide layout. So if you really need something, you can search for it, and you can say, you know, I need mechanism controller. I think this will work. And you know, there we have them: free assets, mechanism controller. There's my my mechanism location. We can see a locomotion starter kit. We can import the package directly. We can open the asset store. We can see that it's free. So we can do this without ever having to open the asset store directly, especially if we know what we're looking for. So let's go back to 102. And we've got our simple particle pack, and this includes a scene file. You can run this, and you can take a look at all of the explosions. Oh, heck, why don't we just do it while we're here? Save. And, you know, with this, you can run through and take a look at things. So there's some flames. So you can, for the people who want to look at Shuriken, these are all done in Shuriken, so you can see how these are done and get an idea of where to get started. We can look at all the explosions in our game. We can use all of these fun things to get us started. And we can use these, and these are available to anybody who wants them. They're free. You can put them in your game. You can modify them. You can change them. So let's go back to our main scene. And so what we need is our enemy to instantiate an explosion when it blows up. How are we going to do that? Well, the first thing we need is our enemy controller, and it's going to need a reference, a public game object reference to its explosion. Let's call this explosion. Let's lowercase e, crackers. Explosion enemy. So there's our explosion enemy. And then when all of this on trigger happy stuff happens, we can instantiate. But where have we seen this before? So again, instead of trying to bang out all this code, we can look for where we've seen an instantiate. And we can simply paste that in, and we want to instantiate the enemy explosion. And where do we want to do this? At our transform position and our transform rotation. Come back and test. We need to drag in something for this slot. So we go to our resources. There are our explosions, and here are a bunch of prefabs. So we can just pick them, drop them in the scene, see how they look. Well, it's a bit slow. It's all a bit slow. Oh, these just pop, don't they? How about that? Flash ring 1. So let's get rid of these other guys. Now, sort of a little bit of a little side trick that I've got here, which is that if we look at this prefab, it's always going to be associated with the prefab in this bundle. And I may need to make changes to this game object, and I don't want to sort of mess up my default particle pack. Even though it belongs to my project, I'm going to feel more comfortable if I can modify this. Now I can duplicate that asset and copy it into my prefabs folder, but I can also take this instance and put it in the prefabs folder and create a new prefab. And we can see that it's now associated with this asset, not with the one down here. And so I can rename this explosion enemy. There's my explosion enemy. I can delete the instance, hit save, look at my enemy, drag that in, and hit play. Oh, that's going to be way big in the game. Anyway, that's all right. So now that works. The only problem I have with this is that if I drive my player ship into it, there's only one explosion. And this makes me feel uncomfortable because I don't mind that the shot disappears and we see the cube blow up. But I want to see something that my player blows up, makes me feel more satisfied. So let's look for a different explosion. Nice big one. Let's try that shock flash. Nice big one. Again, that same sort of thing. I'm going to re-target that prefab. And then I'm going to delete the instance. And then I'm going to call this the explosion player. And in my script now, what I need another one of these. I need a public game object reference to my explosion player. But I can't simply duplicate this and change this to explosion player because this means every time that shot goes off, I'm going to get the explosion player as well. I need to test this. So if my other .gameObject.tag is the same as double equals player. So if my other.gameObject.tag is the same as player, whoops, then I want to instantiate that explosion player, and where? At the other transform position and the other transform rotation. So I can save this, come back to Unity, take a look at my enemy, and I need to drag my player explosion over, hit save, hit play, and now when I, whoa, what did we not see? Oh, because I haven't hit player. Feeling silly. We have to tag our player as player. If we don't tag our player as player, we can't tell it's the player, can we? So that was because the other.gameObject.tag was not the same as player. Now it should be. Boom. So we've got two very big explosions in our scene. So there's our enemy. And there are our explosions. So we now need to move the enemy. And where have we seen the enemy have seen some movement? Now, I will say flat out that this is probably not the most efficient way of doing things. I'm about to copy this from the shot controller. We should probably have a generic movement controller that we can apply both to the enemy and to the shot controller. It just gets a tad bit complicated in this context of making very quick down and dirty code for you guys. But if we made a more generic movement controller that could then look at things going up the screen and going down the screen, and whether we left the screen from the top or the bottom, we could then apply that to both game objects. But in this case, I'm going to simply copy the code in a little bit of an uncomfortable manner, because we should never be really copying and pasting code that is identical between two things. And then we want to make this from Zmax to Zmin. And then we want to go minus vector 3 forward. So we're now having Zmin. We come down the game board, and then we are less than Zmin. we then destroy the game object. We've essentially just reversed this movement code. So if the float is speed and we have a z-min location, and then every frame we translate minus vector 3 forward in space world, and then if we leave the bottom of the game board, we destroy the game object. So we can come to our enemy, and we can see that we have speed. Let's go the same speed as our player, and our z-min, that's going to be, what's that, virtually minus 6. So let's say that's minus 6. Yeah, these particles you can use in 2D games or 3D games. They are arguably three-dimensional, these particles. They do take place in 3D space. These particles are moving around in 3D space, but they're always flat little billboards. Let's put on textured and wireframe and try this again. And you can see that there are a bunch of little quads that are always facing the camera. So let's test this. Let's hit play and let's get ready to get out of the way. Whoa, yep. So we can see that our enemy is moving now down the game board, and we can see that when he leaves the game board, he's removed. Now let's go ahead and let's go ahead and save this as a prefab. So we now have a prefab for that. And now we need a game controller. We need a script that controls our game, that script that keeps track of where our game state is, spawns our enemies in waves, starts and ends the game, displays our UI and our heads-up display. Yeah, you can. We can do that with animations. You can do that with math code. You could be using sine waves, that sort of thing, to move the character, and then you could also be applying another value to it so the sine wave does something. In this case, we don't really have time to get into it. We can sort of fuss with that in Q&A, but what we're going to do here is they're just going to come straight down at us, and you could later on say, change the cubes to asteroids or whatever, and so that your character's flying through an asteroid field. You can change whatever you want them to be. But let's make our game controller. So we're going to need a game object, right? A new empty game object, and that new empty game object is going to be called our game controller. I'm going to reset this to origin, and I'm going to, we don't need to tag it just yet. Reset it to origin, and let's add a new component, and let's call it game controller. So that's our game controller script. And this game object is not going to have a rigid body. It's not going to have a mesh. It's not going to have a renderer. It's not going to have a collider. It's not going to actually physically do anything in our script or in our game. It's going to reach out into our scene, and it's going to manipulate our scene and our game from this sort of invisible position. That's sort of a habit, actually. In this case, we don't have. When it's in the hierarchy, it doesn't make a difference, because in the hierarchy, you always will be looking at these as a name. So these are always going to be string lookups. I think it's probably arguably important to avoid spaces in the project view because these are assets. And there are occasional times when you need something that's looking up an asset path. Um, and if it bumps into spaces, can occasionally run into problems. Let's say you're trying to get a hold of this Flash 01, and there is a space in it, and in the asset path, it's going to be assets, your project, your assets, uh, uh, prefabs, enemy space explosion space enemy, Flash 01, and so there is the chance that that could mess up some specific editor scripting that you're writing. These are things that you'd be writing yourself or you'd be buying as a plugin. So I generally avoid spaces in my asset names, but in your hierarchy, you can use anything you want to. I have a tendency when you get into the habit of writing script names, which script names cannot have spaces because they can't be spaces. And so these could all arguably have spaces in them without breaking anything because they're in your game. That you write spawn point and player ship so many times, it's almost habit for me to not put spaces in them. You can get collision callbacks now from particles, and there are also other things that you can do to look for that. They're peculiar things, but let me push forward because we're supposed to be done in about a half an hour, and I feel like we're just on the edge of getting done on time, and we can save some of these for Q&A. So we've got our game controller with our game controller script. There's our game controller script, so let's file it away and then open that up in MonoDevelop. So what do we want to do? Well, the main thing we want our game controller script to do is spawn our enemies. So that first thing we need is a public game object reference to our enemy. And then we need a function that is going to spawn our waves. And this doesn't get called by Unity. It's our function. It's not an event. So unlike start and wake and function update, it's not going to happen. So we have to call it ourselves. So in start, we can call spawn waves. So Unity will call start when this game object is first enabled, or when this component is first enabled on this game object, and then we, in that start function, call spawn waves, and then spawn waves will start ticking over and spawning our enemies. So how do we do that? Well, we instantiate it, of course. We've seen instantiate before. So we can grab instantiate again and copy that, paste that into our game controller. And what do we want to instantiate? We want to instantiate our enemy at some spawn position with some quaternion spawn rotation. And this, remember, is an object, a generic object, a vector 3, and a quaternion. Again, how do we start filling these out? I mean, if we did it this way, to be totally pedantic, it's an object at a position and a rotation. And the object is easy. It's our enemy. Our rotation is probably the next easiest thing, except it's a quaternion. Now, I've been trying to avoid looking at quaternions, but I can't imagine how we can't, because we're not creating a spawn point. We can't create a spawn point that will give us a position and a quaternion, because we need our enemies to be more than one point. They can't come from one point in the game. Otherwise, it'd be very boring. Our player would just line up under that point and just blow away the enemies. Boring. So let's see what these quaternion functions that we use 99% of the time can do for us. Well, set and two-angle axis and all of this doesn't really help. We could arguably use quaternion Euler, which gives a rotation of z, x, and y degrees in that order. But there's this thing called quaternion.identity, and this is perfectly aligned to world or parent axes. So we can just grab quaternion identity and just say, we want this to be spawned with no rotation. And since we're just creating that game object and it's coming down, why not? No rotation is fine for me. That only leaves spawn position. Now, where is our spawn position? Well, our spawn position is, and we've seen this before, it's a vector 3. And a vector 3 is made up of an x, a y, and a z. So, what are our x, y, and z's? Again, relatively easy to do. Our y, 0. Our z, off the game board. So up here somewhere. Let's say 26, so we're clearly off the game board. So 0, 26. Where's our x? Well, our x can't really be a single number, because if it's a single number, it simply has to be in one place. And again, our player would line up underneath it. We want it to be randomly from the left side to the right side of the game board. So what we really want x to be is random. You can kind of. There is a random class. So you could look at seed and value and inside a unit sphere or a circle or on a unit sphere, a random rotation and a random range. And random ranges, you simply give it a min and a max, and it'll return a value between min and max. The only gotcha is if you use ints, because ints are designed for zero-based lists, and it will never return max. So if we say between -9 and 9, we'll get a number between -9 and 9. If we said we want a function using an int, and we say between -9 as an int and 9, we will get between -9 and 8. Now that seems funny until you think of, I want, if you see here, application load level, random range 0, because my list is a zero-based list, and my application level count. So if you think about this, if I have 10 levels in my game, and I say, and my level count is going to be 10, I want a random range between 0 and level count, but my 10 slots for my 10 levels are going to be 0 through 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I don't want to return 10. This particular random range in ints are customized for zero-based lists, and just be aware of that. For us, we're using floats. It's unimportant. We want a random range, and that random range is from -9.0 to 9.0. So we can save this, and then we need to make this we want to take spawn position. We could just copy this into that point, but it's a little bit cleaner and more elegant to say our vector 3 spawn position is equal to a new vector 3 random range 9, 0, 26. Come back to Unity, let it compile, let's hit play. Oh, and we've got the, let's remove that one, and let's actually put that reference in, our enemy reference, save that, let's hit play. Now we'll see it's randomly generating our enemies from different points off the game board on that center plane, randomly between 9 and -9. So similar to getting that random within our clamp, we're getting random between the ranges that we want. Now, how do we get multiple versions of this? Let's say we want 10 of them, some number of them. We could copy this, paste it a bunch of times. Isn't that good programming? Well, this kind of works. They're spawning, they're bumping into each other, but crackers, is that the wrong way to code? Exactly, loops. If you need to copy and paste code a bunch of times, and I'm right on the edge with this enemy controller thing, where we've copied and pasted this shot controller with only a small change, but this is identical code. You don't do that. You need to run through this with a loop. And loops essentially go through a bunch of code a number of times based on how often you ask it to do that. And the first type of loop we want to do is a for loop. Let's say we have an enemy count. We have to say how many times we want to be here. So a public int called enemy count, and let's say it's equal to 10. So we want to go through this 10 times. So what we can say is make an int called I. Could be anything, could be Captain Kirk. But let's call it I. It's the most common thing to use when you're iterating through a loop, and it's equal to 0. Then semicolon. And we stay in the loop as long as I is less than enemy count. Now we need a way to increment I, either inside the loop in the code, or here we say every time we go through the loop, we increment I by 1. So we save this. Captain Kirk is always a great example. And we save this, and we can come back to Unity, and we can hit play. And notice I didn't need to, because we were talking about the difference. I didn't need to set that value because it set that value as a default inside the script. Hit play, and we're getting a random 10 of these guys every time. Most of them are blowing up on each other because they come into contact. Now, this is kind of annoying because I don't want all of these guys to appear at the same time. I want them to appear, like Zerkiel says, every few seconds or every half second. But when we execute our code, we execute every line of code, one line at a time, until we reach the end of our function, and then we, in the case of update, render a frame. If we were suddenly to stop, the whole game would stop. If we just went down here and we said, wait, oh, wait, well, our game would just stop. It would stop it all completely until we were done waiting, and then it would just start going again. But there are times when we want to pause one part of our game and have the rest of the game continue to run. There are times when we say we go and we have a function running. It says, first thing the function does is download some information or a JPEG from the internet, and then it needs to apply that JPEG to a texture, but it only can do it when it's done downloading, and that's going to take some time. We, again, don't want our game to stop. Well, Unity gives us something called a coroutine. Now, coroutines allow you to pause inside the coroutine, arguably, function. In JavaScript, you don't need to be very pedantic about it at all. You can simply just say, in the middle of a function, yield, wait for seconds. In C#, we have to be a little bit more pedantic. One of the first things we have to make sure we do is we have to actively start the coroutine. We can't just call it as a function. We have to identify it as a coroutine and start it. Our coroutine has to return IEnumerator. Not IEnumerable, but IEnumerator. I don't want to go into the detail of the blocks and that sort of stuff that's going on under the hood. And so once we explicitly start it, and then we return IEnumerator, we're allowed to then say, here I want to yield and I want to return a new wait for seconds. And the wait for seconds I want to wait is 0.5 seconds. And what this will do is we'll start our loop. We'll create a spawn position. We will spawn our enemy at that spawn position with no rotation, and then we stop. And then we do it again until our enemy count equals 10. So let's save this. Let's come back to Unity. Let's hit play. And notice that they're now coming at half-second intervals all the way till we're done having our 10. Now, you could make a random wait for seconds. I've just made them trickle down, so you could do anything you want to with it. But that's what's so fun about coding, is that you can now add a random range. So they come down right after each other or next to each other. You may end up getting collisions. The one thing with this picking a half second is that I know that these guys are going the same speed and they aren't going to collide with each other. You do end up sometimes creating a problem you have to creatively solve, but that's what makes a cool game. But the problem I have is that the game is still running. My 10 enemies are gone. I could crank this up to 1,000,000, but then I get a waterfall of enemies. I want waves. So let's put this loop in another loop. Uh-oh. Did everyone lose sound? Okay. Whoo. Cool. So this new loop I'm going to put you in is a while. Learn how to spell a while loop. And while loops, you can stay inside this while loop as long as the content inside these brackets returns true. So as long as A is greater than B, we stay inside this loop. As soon as A is no longer greater than B and it is false, we fall out the bottom and we're done with it. On the other hand, if I want to stay in this loop forever, I can say while true. And then with this, I stay, and we'll talk about how to break out of this later on, but this will be forever. And again, I want another yield wait for seconds, but I want to do that down here. And I want to wait for enough to clear the entire game board, which is about 3 seconds. So I'm going to stay in this loop, and then I'm going to do it 10 times. Then I'm going to wait 3 seconds, and then do it again. So we can hit play. And, here's my bad guys. Blow them up. That's 10. And then we clear the wave, and there is another wave. And you can start being clever with this. You can count your waves and come up with some way of graphically displaying how many waves you've gone through. But, for now, this will go on forever. It will also go on after my player has blown up. But hey, we'll talk about how to get out of that later. What we did notice was that there were a whole bunch of explosions left behind. So we can see those explosion enemy clones are, being left behind, even our player explosion. We can't really destroy these by distance because they never leave the game board. So we can destroy them by time. So let's create a new generic script. Let's make it a C# script. Let's call this auto destruct. And we're going to open up auto destruct, and we're going to write very simple small lines of code. In start, so at the start of the game, I'm going to say destroy, or in the start of when this is instantiated, destroy game object. Now, wait a second. You say, we're going to destroy it on the first frame. So it appears in the game world, we instantiate it, and then we destroy it. That seems really, really silly. Well, that's because we haven't looked very closely at destroy. Destroy is actually a very powerful function. You can destroy an object, and you have an optional time. So we've been using it as just simply destroy the game object. By reference, it destroys the game object. It also destroys all of the contents of that game object. You can use it to remove game objects, components, or assets. So you can say, destroy this, and it simply removes the component that this line of script is in. You can find something by reference and say, destroy the rigid body. If you need the rigid body removed, just destroy it. But there could be a point in your game where you don't want that rigid body, where you don't want that box collider. So you can just destroy it. You can also destroy in time. So what I want to do here in my script is destroy. Now I could put in some number, but then I don't have a versatile and reusable script. So I can create a public float called lifetime. And then I can say destroy this game object in lifetime. And now I can use this throughout my game on any game object I want to auto-destruct by time. So I can put that on my explosion enemy. I can put it on my explosion player. And then I can set these to be different times. I'm going to set them both to 2 because it's good. But now I can hit save. I can hit play. And now, since I put that onto the prefab asset, notice that those explosions are all going away after 2 seconds. So as long as the explosion effect is less than 2 seconds, it'll even go take that player explosion and get rid of it as well. I mean, you could tie it into, you could write a script that tied it into the lifetime of the particle system. But in this case, you know, and again, we're not being tricky, is that you'd have to get a reference, the destruct script would have to get a reference to the particle system and find the lifetime value, and it would only work on particle systems. Whereas this, as long as I set that value by hand, I can destroy anything, and I could put it on the player. Let's destroy this in 2 seconds. You know, yay. Not really very practical, but you could. Sorry, when we say yield return x, x is the condition when we would come back to the coroutine. Yeah, essentially, we pause at that point for that many seconds, and then you return at that line that many seconds later. So we need some sounds. We are running a little bit late because I'm not sure I can finish this in 12 minutes, but I'll push. So our sounds, we can go to a place called BFXer. Now, BFXer is a sound generation website, and he's given me permission to use it here. Anyway, it's free. It's open source as far as I know. And it's royalty free. You can use any of these sounds to do anything you want to with them. I do have to be up early to get my son to school. Thank you. And I was moving rubble again today, but that's a whole nother question. So let's pick some sounds. We need some explosion sounds, and we need some laser shoot sounds. Let's go for a nice quick one for our enemy. So once we pick one, we can save it. I'm going to put that on my desktop, U3D-102, in our assets directory, in our folder called audio. And let's call this explosion enemy dot wave. And let's pick another one for our player. Oh, power up. I want an explosion. Oh, come on. Give me a good player one. says our game is over. I'm about to give up on you, BFXer. You've done me better. All right, good enough. One more? No. Nope. We'll export that one. That's going to be our explosion player. And then let's find a laser shoot sound. That looks good. Let's export that one as laser shoot. So let's say goodbye to BFXer and come back to Unity, and we can see that we have an audio folder, and this has now 3 audio clips. So now we've got our audio clips. This is a new importer. We can choose whether we want to leave it native format or compressed, whether it's a 3D sound, and I'll explain what this means better later, and then how we want to deal with the asset. Do we load it into memory, stream from disk? Both have their own advantages and disadvantages on how you use your resources. There's a preview window at the bottom, and you can choose to play it. You can loop it. And to generally see what you want to find out about the sound clip, and there's information down at the bottom, how much space it's taking, and then more information about its bit rate and its speed. And there are 3 basic components that we have inside Unity for dealing with sound. There are some zones and filters, but primarily we deal with clips, sources, and a listener. We've seen clips. These are the clips here. Clips contain our audio file. Sources play them back from our game world, and the audio listener grabs all of those sounds, mixes them together, and puts them into our speakers and our headsets. Now, the easiest way to get an audio source onto a game object is to just drag the sound we want onto the game object we want. So we can simply grab that clip, drop it onto the explosion player, and we can see that it has added an audio source, and that audio source has linked the audio clip. So explosion enemy, same thing. And in this architecture, we are dragging these on directly to the game object. The sound will be instantiated when we create the game object. We create the explosion visual effect, and then we also play the explosion sound. When you're looking at the details of the audio source, we can see it has a clip that's associated with it. Some essentially effects here, whether it's muted, whether you want to bypass the effects on it. Play on awake, which we want, so we instantiate that explosion, and we immediately want this to play. We do not want it to loop, so it plays once and then it's over. Things like volume and pitch, these are exposed in the editor, but they're usually just run through with code. Good use of pitch and volume to change them. Imagine footsteps. Is that you can have one sound of, say, footsteps on wood, footsteps on metal, footsteps on snow. And you don't want to have a pool of them. You just want one to keep your game small. But you don't want it to be monotonous. So you'd use that random range. And every time you play the footstep sound, you give it a slightly random volume and a slightly random pitch. And it sounds like these footsteps are unique. So you understand the surface. I'm running on metal, but each footstep has its own sort of unique sound. Doppler level, if you're using 3D sounds, is looking at the relationship between the object's position and speed and the listener's position and speed, and you can get that Doppler effect. Now, what is a 3D sound? Well, 2D sounds, which you can sort of pan left and right, those are things that are like music. Birds chirping, wind rustling in the wind in the leaves, just stuff that's ambient in the environment. 3D sounds are from specific locations. That's the person shooting at you. You can hear his gun. That's the person throwing grenades at you, and you can hear them exploding. It's also the man chopping wood. It's the car driving by, the volcano rumbling, the waterfall, pouring into the lake. They come from a specific point in the game world. So as your character turns, it'll change which speaker it comes into. As your character comes forward or moves away, it gets louder or quieter. You can change that volume. This is the current what's called roll-off, which is how loud it becomes. Right now, the max distance is 500, so you can't hear it beyond 500 units. And then as you get closer, it just gets loud very quickly. You can change that to linear, which just means the closer you get, the louder it gets. And with custom, this is a unity curve. You can do anything you want to with it, even be wildly silly and say, I can't hear it when I'm close, but it's very loud when I'm far away. Kind of crazy, but hey, it's your game. I'll leave that at logarithmic. So these are sources and audio listeners. There's always a default audio listener on the main camera. You can turn it on or turn it off. You can enable or disable it, but there's no other settings for it. And it simply listens to all of the sounds in your game. If you are in range, mixes them together and puts them in your speakers or headphones. Now, if you've got two audio listeners that are active in the scene, you're going to get a console full of errors saying there are two audio listeners here. Please have only one active. Now the thing is, it's a little bit of a misnomer here. It's not that you can't have two audio listeners in the scene. You don't want to have two audio listeners that are active or enabled in the scene. So if I've got one of them turned off, I'm not going to get that error until I turn on that audio listener. And then when two of them are enabled, you'll start getting that every frame. So just be aware there's always one on the main camera, there's always one on the default camera, and you only want one running at any one time because your game can only have one perspective from which to render the sound. So for our player ship, we drag the laser shoot on it. Now we don't want this to play on awake. We want this to play when we pull our trigger. So this is back to our script. In our player controller, when we fire that shot, we simply want to say audio. We use the shorthand, the lowercase a, which will grab that audio component, play. And it's a function, so you need the parentheses afterwards. In this architecture, it does not play on awake, it does not loop, but it will play every time we fire the weapon. Now, let me turn up the sound a little bit. Yeah, you can have more sources on one object doing different things, but then getting the reference to it becomes more complicated. If you had your cube, and then you had, there's the explosion enemy, there's the explosion. You could have multiple ones on these. Oh, I guess you can't. Explosion player. It's replacing it. I must have done some chaining stuff. I've had chains of them where I've made, but I think they must have been children. I'm replacing the clip because I remembered I had these little game objects with multiple audio sources on them, and you could just send as many sounds as if you wanted to this family, and if it needed another one, it just would create it for you. And I guess I must have been putting them all on child objects in a daisy chain. So I guess you can't. So now we've got counting code, and I'm not going to do this in less than 1 minute, so we're going to run a little bit late today. If anyone needs to leave on time, let me know, or you can send a note to e-learning, and I will give you the end product of today. Let me just publish this temporarily to Dropbox. And then I'll just replace it with the final one, export package, export to public, to Come on. But this should only be 5 or 10 more minutes, I hope. So counting code. Counting code in one sense is relatively easy. Where in our game controller, we're going to need a private int for our score. This is a, well, it's going to be 10. It's going to be 10 minutes at least, now that I think about it. So we've got our private int called score. And then in awake, we want to set our score to be equal to 0. Now, before we talk about how to access this private variable, let's hook up a very simple UI. We're not going to go into the details of on GUI, because if we do, we'll be here all night. It's a whole subject in and of itself. So let's just be aware that we have in void on GUI, our UI code goes, and we are going to make a GUI label. And inside our GUI label is going to be a new rect please, a new rect, and inside our new rect is going to be a start X, start Y, width and height. So it'll be 10, 10, so 10 pixels down, 10 pixels in, actually 10 pixels in and 10 pixels down, and then the width of 100 and height of 20, and it's going to say our score, colon space, plus our score, and it's going to do to string automatically for that. So that's going to make a little label in the upper left-hand corner with score. Now, how do we get that score value to go up? Well, it's a private variable, so I can't access it from another script. And I don't want to talk about getters and setters because it's not something you can do in C# and JavaScript. So I'm going to create a public function called addScore. That's going to do it for me. And addScore is going to accept an int as a new score value. And that new score value, we're going to say our score plus equals new score. I've made a mistake somewhere. Value. I'm just going to find out what the error is. Oh, public void, right. Crackers. New score value. No, pretty much I redo the same basic class. I do make changes, subtle changes each time, and then sometimes I update my code periodically, but they are primarily the same thing. So if you came back 2 weeks from now and did it again, we'll probably be going to be making a top-down shooter very similar to this. So we have this new score value. How do we access this public function new score value? Well, we want to access it from our enemy controller. And I could try when we blow up, and I could say I want to add score, and I want to add score some score value. So the first thing I'm going to need is to create a public int called score value so that my enemy has a value to send. But then how do I get a hold of this add score in game controller? I could simply try to say, game controller add score, hit save, come back to Unity, and Unity doesn't like this. An object reference is required to access a non-static member called game controller add score. I'm looking at this on sort of the class level. I'm sort of asking the class itself to add score, but the idea is that these scripts have instances. One instance is on this game object, but I could have, multiple game objects with their own game controller. It would be bad for our game if we did. We only want one. But I need a reference to this specific instance. Well, if I need a reference, I could create a public game controller reference called my game controller. And then I can change game controller here to my game controller. So I now have a specific reference to a specific one. And if I save this and I come to Unity likes it. Okay. So there's my enemy. There's my game controller. And I can't drag a reference. I can't drag a reference because this is an asset and this is an instance in a scene, and my asset can't take a reference to a scene that I may change, I may delete. I may be putting it into another scene. I may have 2 or 3 different scenes with the game controller. So this type of reference doesn't make sense. I need some way that when the enemy gets instantiated, it can then, oops, we want this enemy. When the enemy gets the enemy gets instantiated, I can then set that reference, but I can only do it when the enemy is in the game. So I have to do this at runtime. Well, there are 2 ways I can do this. Either the enemy controller in start needs to go and find the game controller, and you could probably do that by tag, find my game object by tag, and then once I have the game object by tag, I can find the component on it and then fill that reference. The other way to do it is you can push that reference when you instantiate the enemy. So I can here take a game object reference called new enemy equals instantiate that enemy spawn position quaternion.identity as game object. So now I need to know what this is. And then I can get component on that. I can say I'm going to create a reference to the enemy. I've got to grab the, going this way, the game controller has to grab the newly instantiated enemy's enemy controller script and set this value. So I want to say that my enemy controller, which will be, new enemy controller, equals new enemy, but get component. I want to get that component, and the component I want to get is that enemy controller. Does that make sense? So here I'm taking a reference to that new enemy as it's created. I go and find that component on it before I let it go, and then I want to say my new enemy controller dot my game controller equals this. So I'm assigning this value when I instantiate it. I basically create an enemy, find the component, set the value, let it go. So now, if I come back to my game, and let's delete that instance. We don't care about that. We've got our enemy here. We can set that value, say 10 points. The only thing that's a little bit annoying to me is that I see this reference here, and I can't change it. I can't make it private either because the game controller needs to access it. If I want to, just so you know about this, I can ask it to hide in inspector inside square brackets, and then it goes away. So save this, let's hit play. And now we get 10 points even when we commit suicide. Oops. Not quite sure, Seneth, what you're suggesting. Because you have to make this instantiation at, as far as I'm aware, at runtime to the instance. You need an instance in the scene for of the enemy to get the instance reference of the game controller. So ending the game. I've got one last little thing to do to end the game. We need two little private flags here in our game controller. A private bool. Remember, this is short for Boolean, called game over, and a private Boolean called restart. Now, I can set game over the same way I set add score, with a public void game over. And I don't need to take any arguments. I can simply call it and then say my game over equals true. I should also set these two so my game over is false and my restart is false as well. And then I'm going to use these flags to do two things: to break out of spawn waves and to look at some buttons and UI labels that'll tell us when the game is over and when it's safe to restart. The first thing I want to do is break out of my game loop. I want to check here, and I want to do this sort of aesthetically. Oops, this is in the wrong space. I want to do this aesthetically when the screen is cleared. I want to flow up, and then I want to get that tragic moment where you said, "Oh, I've died." All of the cubes clear out, and then I can restart. But I'm just being punished at that point. It's good punishment. So before I basically do the enemies, we wait 3 seconds. But before I go back to the top of the loop, I want to check if game over. And then if game over, I want to say my restart is true. And then I want to break. And break will break me out of this loop. Now, arguably, you could put restart, is if game over here, and run this whole loop with game over and not have to break out of it. But I like to sort of the integrity that this loop is continuing. And then down here, I can check for game over. If it's game over, I set restart to true and I break out. And then with these two flags set to true, game over and restart, we want to look at our labels. And since our labels are code driven, they react to if statements. So if game over. So if the game is over, then I want a GUI label. Oh, come on, not a GUI text. I want a GUI label, please. Can I have a GUI label? A GUI label. And my GUI label is, of course, made of a new rect. And that new rect is made up of a start X, a start Y, a width, and a height. But I'm going to be asking my screen again for its size. I want it to be at screen width, divide by 2, and then screen height, divide by 3. So in the center, but up a little bit. And then I want it to be 80 this time by 20. And then again, remember that this is our start position. So to center this, I need to remove half. And what does this say? Game over, man. And what about if restart? Well, if restart, then we're going to then display a GUI button. But you need to test that with an if as well. So if GUI button. And that GUI button also has a new rect. That new rect is going to be the opposite of my score. My score is 10 pixels down and 10 pixels in. So I can make my, or 10 pixels in and 10 pixels down. So I can do that also by asking for my screen width. And then we'll subtract 70. Because 10 pixels down, I'm going to have a 60 unit wide button, which puts that 10 pixels off the edge, 20 tall. And what does it say? Start. And if we press that GUI button with restart, we want to ask the application to do a load level. And what level do we want to load? Application keeps track of the currently loaded level. So this is how we end the game, but how do we know that the game is over? Well, we know the game is over when the enemy controller blows up the player. So if the other.gameObject.tag is the same as player, let's instantiate that player explosion and my game controller, which we have the access for. Game over. So let's save this and hit play. And so game over. And then when this is cleared, we then can now restart. And you notice we've broken out of the spawn wave, so the waves are no longer coming down. Game is over. Hit restart. Do it again. I'm kind of ignoring the text chat for just a second because I want to quickly finish this up. Last thing to do, I want to create a particle system called stars. And I'm going to reset this transform. And then I'm going to lower it down so it's below the game board. -2 units is probably enough. I mean, we're orthographic, so you can pick any number as long as it's in the frustum. And then looking back at my game board, I want to rotate this around 180 degrees and then push it off the top so that they're coming on, so we can see them entering the game board. And then first thing, let's change our shape from a cone to a box. And then stretch out that box as X till we have particles along the edge. 20 looks 20, please. Looks big enough. So let's pre-warm so we get a full system so we don't see it appearing, so we have a whole screen full. Let's make our lifetime nice and long so it can clear the whole game board. Let's make our speed between 2 values. Between relatively short and medium short. And you can see we're now multiplaning. So we think we have this sense of depth. And then our size also between very small and still kind of small. So now we have a star field moving underneath us. I mean, you could fuss with color if you really wanted to. Give them, red giant colors and, give them 2 random colors or whatever. But, white's just fine for me today. So then when we hit play, we now have a star field moving in our background. So we need to build this, crackers, and get this up on the web. We do that by hitting our build settings, and we need to include our scene. We're setting up for web player, so we can simply just hit build. And this brings up the build web player box, and I'm going to create inside my root project a new folder called builds. And I just completely buggered that up, didn't I? Let's cancel that. And let's go back and fix that because I can't have it called builds. All right. So let's try this again. In the builds folder, let's call this demo build 130716. And we can see we're compiling the scripts and we're building the levels and we're creating a resources folder and we're going to compress that. And when we're done, we're given inside our builds directory a folder, and in that folder is 2 files. And it's relatively small. That whole game is in 147K. 4K wrapper, which is our HTML file. We play the HTML file, and we can see I'm loading this locally. And this will pop up in a second. And now I'm playing locally. But if I want to distribute this, I can do that by opening my Dropbox folder and going to public. And then I can drop in the demo build, the whole folder. And then what I want to distribute right there is the HTML file. And then with that, public, I can follow that link. And I'm playing off the web a published game. And don't forget, these web players are also, you can publish to Congregate, you can publish to quite a few web portals directly. So let me save this. Let me export this package. Export to public. And when that's done syncing, all right. Done. Q&A time. Sorry we ran a little late today. What questions do you have? Well, thank you for coming. I appreciate that. Can I have my custom horizontal and vertical axes in the input manager that are related to touches on mobile devices? No, you need to look. CJ, thank you. You're welcome. Let's look at the input class. Player controller. Input, command single quote, input class. Really what you need to be doing is reading this section because it's really a very different interface. So you're not looking at remappable keyboards. You're not looking at moving devices like joysticks and mice and game controllers. You're looking at input touches. You're looking at your input acceleration. So you're going to be looking at getting input acceleration was a vector 3 and doing something with that acceleration in your game. You're welcome. Both positive and negative. If you have any comments, leave them on the website. Not that one. That one. So things you want to see changed, different, more of, less of, put it there because that's where people read it, the powers that be. So if you loved it, you hated it, you want to see purple spaceships instead of green ones, put it on that link. So when you're dealing with your input acceleration, now you can also use something called platform custom platform compiles, platform dependent compilation. That's what I'm looking for. And there's two uses for platform dependent compilation. One is if you're making a plugin and you want it to be usable for multiple versions of Unity. If you look at this code here in Simple Particle Pack, and then you look at the scripts and you look at Particle Tester, we will note that it has an if Unity 3.4 or 3.5, then we're using set active recursively, which was depreciated, or else use set active false. And I sort of made the decision that anybody who had a version of Unity that was before 3.4, tough. It would default to this, and it would be kind of breaky. But if you're using 3, you should be up to 3.4 or 3.5 at this point. And there isn't a real convenient, if version 3, I'd have to have ors with all of these. So, oh, there's a version 3. Oh no, it's 3.0. I think I've had this gone around in circles. This is 3.0, not just 3. Yeah, there's no 3x, unfortunately. So you can also use these for your platform compilation. So you can say if Unity iPhone, if Unity Android. So an example would be if we wanted to change this code around. We have our player controller. We have our input get access. So we could say hash if, and you can see the examples down here, Unity iPhone. Or I could say hash if not Unity iPhone. This, and then you could say hash else. So this would be Unity iPhone, and I'll explain partly why I want to do this. And else, please. And then hash end. You could say I want my. Let me move this up as well. So this is all in one define. We've got movement there. You could say if it's Unity iPhone, I want a vector 3. And this is not really going to work, but you're going to get an idea. Movement equals input dot acceleration that's a variable, isn't it? Input acceleration. Yeah, it's vector 3. I mean, so this is going to be a bit funky. And then you can see I'm translating my movement. And in this chunk, I get it from my keyboard and mice because it's not Unity iPhone, or, Unity Android. And then I get my movement here, and then I'm using this transform translate, and it works fine regardless of where I get my input from, if that makes sense. Can we turn kinematics or gravity on and off via scripts? Yes. You can do that. I mean, you have access as long as it's public. You can fuss with it. It's exposed, so you can say, let's find something. I suppose you could say something really silly. if input dot get button I'm trying to think of a good button to get. Let's just look at the input manager. What's fire 2? Left alt. Okay, fire 2. If input get button fire 2, rigid body dot is kinematic equals false. Rigid body use gravity equals true. Now this is going to be very silly. Don't do this. But if you save this, that's fire 1 again. Let's make it fire 2. So we could play our game, and then left alt button. We're actually, oh, come on, we didn't see that. Left alt? That should be left alt. We're not blowing up. Come on. Let's play our game down here. What am I doing wrong? If input get button fire 2, rigid body is kinematic, it's false. Do we have a rigid body on there? Player, rigid body, save, play, and then F2. Use gravity. I'm surprised we're not falling. Now this is surprising me a little bit because I would have thought that would have worked. The player controller. Let me quickly turn off the game controller so I don't have bad things running at me. And then let's look at our player ship. All right, let's do some quick debugging again. Maybe my fire 2 is not working. Debug.log, fire 2. So we just need, this is just testing to make sure I'm hitting the key correctly because, you know, a little base debugging. So hit play. So my fire 2, oh, the fire 2 button is working. Oh, there it is. Is kinematic is off? That is working. But I'm surprised we're not falling. Oh, and this is also, again, what I did when we were debugging yesterday. What are we doing in our script? We're clamping it so we can't move. So we're always clamped every frame to 0. So this experiment is really bad. Let's get rid of that clamp to prove my point. There we go. That's what I wanted to do. But this is the interesting, to me, always the interesting thing you have to be really careful with when you're doing your scripting. And it's partly why some people with scripting get very pedantic about the way things work, is that often you write a system and the system is working just fine, and then you forget how things are integrated, is that our ship was being held by inside the game board with X and Y. We also set our X and Z, and we set our Y to 0. So even though we've become a non-kinematic gravity-using rigid body active object, this transform position is forcing us to stay there on the 0 plane. So let's get rid of all this silly stuff. But yes, that was a very silly way of saying, yes, you can grab those parameters. I'm back reading. So the first one is regarding iOS development. What do I have to think about when developing for iOS? I think the biggest thing you have to think about when developing for iOS is just the, I would say, technically, the limits of the device, because it is a small handheld device. It's not even as robust as the web player. You have to be aware of draw calls. You have to be aware of the amount of resources you're pushing through that. And there's a lot of hoops and tricks that people go through to get a good-looking device, a good-looking game shoved into that tiny device. All that power, tiny little space. And the other thing that you need to think about is how your game will translate. I mean, this game at first starts to think, oh, it looks a little bit nice and iOS-y. It's a small game. It's in an upright place. But then using the keyboards for mouse for left and right and then fire, suddenly you need 3 buttons, 4 buttons, 5 buttons. You need somehow of going left, right, up, and down in a fire. Suppose you can have a virtual D-pad of some sort or a thumb pad, and another fire button. So you have to think about how the user interface translates. The same way as some of the things don't translate out of iOS. You can't really do Ninja Fruit Slice or Angry Birds. It doesn't really work when you're pulling back a mouse. It's really nice and tactile when you're using your fingers. So I would say the two big things with iOS is, what are the technical limitations? Can you put the vert count? You're not going to be able to shove an Worlds of Warcraft or Guild Wars 2 game into a little device, but also the interface. What can the people do? I have a game that I've done. Let me bring this up. Open project, Spacelight Sim. And this is a very stale project again. Works on iOS, works on web player. But if we look at the, turn that down. Whoa, wrong thing. I mean, so this is generally just a little space shoot 'em up. Let me just put this on maximize on play. And, didn't mean to do that. And the point I have here is this is what it would look like when you're playing off the web. Relatively straightforward. But now let's take a look at the same aspect ratio when you have to do this for iOS. And look at how much more of the screen space is suddenly lost to, well, I've lost my vectrosity stuff there. Let me just turn these guys all back on. Even there's my joystick left. So play. So look at the amount of real estate I said that you're losing to just getting controls on screen, and then this is shoved down it's shoved down a device that's much smaller than this. So, and this the bright colors and that sort of thing was just for testing. I was just laying out where your hands could go and what the buttons could do, and so you need to be really aware of the interface differences. You need to be aware of the restriction of size and shape. And also, does this game translate with all of these keys and stuff? Is it really a game that someone's going to like playing on the iPhone because their thumbs are all over the place and there's no sensation? Anyway, is there a way to unify input and handle mouse clicks and touch? Similar to what I was showing, partly we're out of sync because of the way the questions work, but those platform-dependent compilations is a way to unify input and touch handling. So you've got the mouse clicks when you're in the editor or on your standalone, but you're using that platform-dependent compilation for your iPhone when you compile to iPhone or Android. Making a universal game for both iPhone and iPad is just learning the settings, but again, you have to worry about your UI. Is the game fundamentally different on the iPhone and iPad? And if it is, you may need to change your interface. You may need to change the way people approach the game. And then you can do some testing harder on Android, but on iPhone, you can do things like iPhone generation. Is it iPhone generation? Yep. And so you can say, what device am I on? And so I'm on an iPad. Cool. Then this is your interface. Oh, I'm on an iPhone. This is another one. And updating your game on the App Store, that's just a question of uploading a new binary, and that's learning the interface with iTunes Connect and that sort of thing. Sort of beyond what we can talk about here, and also it changes all the time. And I haven't done anything up on the App Store in about a year, and they do change all the time. So you need to see how they're doing their stuff there in iTunes Connect. M Night, next series, put that down on the website, and I'll see if I can get to it. Just more pressure, more things for us to respond to. Do I have to take care for Retina resolutions? Arguably, yeah. Resolution independence is a difficult subject. There are some people who claim that their asset store project will help you. Or is it platform? Multi-platform toolkit. So you could look around. Some of these people have come up with, I think there's a couple of these, and you can see they're usually not cheap. And I don't know if they really are an end-to-end multi-platform solution, as they say, but they're claiming Windows Phone, Windows 8, iPhone 5, iPad, Retina, Flash, NACL, whatever they are giving you will help you make your game platform independent. There are tools in some of the UIs. If you look at the UI extensions like NGUI and EasyGUI, both have ways of anchoring your UI to edges and corners and that sort of thing. So as your resolution changes, you still have a very similar layout and gameplay. What's the best approach to game optimization? Don't do too much and don't do too little. How hard you push optimization and how early is really a question of great debate. And it's somewhat of just staying in the loop and starting to read people's blogs. There is the general trend of don't optimize too early because you can paint yourself into a corner. On the other hand, you hear about people who don't keep optimization as an idea in the back of their head and write a game that's so out there that it needs to be optimized. It needs to get 4 times the frame rate and half the file size, and they have to rewrite the game from the ground up because they didn't consider any optimization while they were building it. So some of that is just learning to make games, but things like you can pool your objects. You can prevent a thing called allocations where you're writing information into temporary variables that then get cleaned up so that there's a big garbage collection phase. So there are some things that you can learn about. And a lot of that is just generally reading about how to script and that sort of thing. And some of it is also playing around on your own time and saying, can I make this model look good with a resolution that's half the size? Or what a lot of games often do is they have high resolution textures and very low poly models. That sort of thing. A couple of questions on audio. Is it possible to attenuate 3D sounds based on the surrounding geometry, making it quieter behind a wall? There are zones. I haven't played as much with sound in Unity as I'd like. I have a sound background, but I haven't played with Unity as much. We have now zones and filters that you can apply and use. And this can help I'm sure that this type of thing will also help if you have a single player game, because you can start to do things like say, I'm hearing a sound. Is there a wall between me? And physically change the the loudness in the component. Whereas if you had, say, a multiplayer game, you're going to have to run that not on the server. You'll have to run it on the, or you could run it on the server, I suppose. But you'd have to be making tests for each individual person. It gets a little more complicated. But definitely look at the audio components. Look at reverb zones, and then look at your filters. And then also look at stealth, because they did something funky with the footsteps, which were just like that. And I haven't done the stealth tutorial yet, but the idea is that you could be next to someone, there's a wall in between and a doorway at the end of the hallway, and it made a difference. And I think that was primarily inside the code, which is you don't hear the difference, but like the guard won't hear your footsteps because you're that far, and you could probably apply that technique to the audio listener or to the audio, the audio source, and vary the actual sound volume. Is the package ready for download? It should be. Um, I think I posted that. I can share the link again. That's not the link. Still back reading, trying to catch up to you guys. I've heard many things about Maya versus Blender, but which of these two is closer to your heart and why? Some of it comes down to money. Maya is a very powerful tool. I've supervised high-end visual effects with people using Maya, and it's been brilliant. On the other hand, Blender is free. And if you're looking at a budget and you want to be able to make professional grade models and not spend thousands of dollars on your modeling package, Blender does just stick out at the top, because there's a lot of affordable commercial packages available that just don't have the power. Blender, though, is as said, is open source, and at one point they did an upgrade from, I think it was 2.4 to 2.5 or 2.5 to 2.6, and nobody translated the bevel script for years. And it's like, where's the bevel script? It was really great. Oh, well, no one's gotten around to doing that. So it's an open source free thing as well. So it can kick you in the backside. If you have a big studio running and you've got money involved and you can't afford a professional license like Maya, then I'd be careful about running my business on freeware, open source freeware. But it is a powerful modeling program, and with the exception of some stuff I've done in Modo recently, all of the work I've done since moving into game design has been in Blender. Does that answer your question? Waffling a little bit? Do you have any suggestions for where to learn Blender, making models, materials? I wouldn't worry about making materials. Don't make materials in Blender, other than simply linking up maybe a temp image or the same image from Unity, partly because you have to learn a whole new materials architecture, and it will not carry over. The thing that carries over from your modeling is the UV maps, how those materials are attached, rather than the materials themselves. So it doesn't make a difference if in Blender it looks glossy, if it looks matte, if it looks transparent. All of that you have to redo when you get it into Unity. Where to learn Blender? Unfortunately, you're stuck on YouTube. And fussing around and asking questions on the IRC chat channels. But there are a lot of resources. The biggest problem with Blender is not that there aren't enough resources, that there are too many. And so trying to find resources that are good and up to date, because sometimes you look at something and you go, oh, the title for that sounds really great. And you realize that they're in a 5-year-old, 6-year-old version of Blender, and it is irrelevant. It doesn't make sense anymore. The buttons aren't where they are. The names are different. So the biggest problem with Blender is there's a lot of information, and trying to find good information is difficult. What fancy plugins? What was that fancy plugin in your Finder? Oh, where? I mean, just Blender, a Unity Blender plugin. What kind of object is a game controller? It is just a game object. Oh, let's bring back that. So the game controller is just an empty game object that contains a script. I mean, I have seen people who put these types of scripts on their main cameras because they don't need a location. There are some people who feel that the main camera is where they put, all of these generic scripts that don't have rigid bodies, they don't have renderers, they don't have meshes, and they put them on the camera because they just need a game object to be attached to. They need to be instantiated in the scene somehow to work. I like to see my individual controllers with game objects, and I can group them, I can move them around. I want my camera to be independent. I want to be able to delete my camera if I don't need it without accidentally taking something important with it. But just a game object with a script. And the scripts have to be attached to a game object to be instantiated to work. So I've attached it to something called game controller. Um, you cannot transfer materials. This is Anguez. You can't transfer materials from other applications into Unity, and just the same way that you can't take Unity materials and put them into other applications. Now, when you're looking at shader code, you can often translate shader code because it's a much more generic code. It comes from primarily from NVIDIA. HLSL or GL or CG code is written not by Unity but by graphics card companies. So you can break down. There are times where people have looked at stuff like, there's an ocean shader that people use in Unreal. What does the shader look like? It's written in HLSL. Bring it into Unity and start to monkey with it until they can get it to work inside Unity. So yes, you can't move materials. You can move UV maps. Do you have any ready to go animations in Blender to show how you import them into Unity? No. The best thing to look at is the Mechanim demos. Maybe we could bring in some animations. Asset store is empty. There's nothing on the asset store anymore, folks. It's all been sold. I'm sort of afraid to open this can of worms, partly because we've got 5 minutes before 1, and I'll stay a little bit longer because I know we ran late. But Mechanim, oh, this is going to take forever to import, isn't it? Take a look at Mechanim. Take a look at the example scenes. There's a whole bunch of Mechanim stuff. Take a look at the stuff from Unity. to see how they put things together. There's a bunch of raw mocap data files that you can attach. Um, let's let that come in. Let me talk about animations in a second when that's done processing. Um, David, just talking back about that clamp, could you adjust the clamp? Yes, you can simulate gravity if you want to, because it's just an acceleration. Um, it was just one of those things that sort of surprised me, where I'd forgotten that we had clamped ourselves on the Y. Why isn't it falling? Um, but then but if you simulate gravity, you're not actually. It was sort of partly for that example of showing you can turn off the kinematic and make sure gravity is turned on your rigid body. Well, the game controller was not touched, Joel, until the end. Um, so the game controller is very simply, we're importing. It's just simply a game object with one script. And the idea is that if you are taking references to other scripts and you're doing things, you don't need to have, like our enemies, they've got a rigid body. We're moving them in the scene. They've got a collider. Our player has a rigid body. There's a collider. We're moving in the scene. So do our shots. And suddenly we've got this sort of different type of game object, which is simply holding scripts that do things that control our game. It's spawning things. It's reaching out and assigning values. It's taking values back in. It's checking to see if the game is over. Checking to see if it's okay to restart. But it doesn't actually sort of exist in that sort of sense of it's not an instantiated mesh with a collider in our game. You're able to post. I'm reading M Night. He asked if you can post that game. You can post anything you want to because it comes from Unity, so you can use it. But also, yes, you can put any. I mean, web player games. You save them to disk and then you publish them as web pages on your own website, or in this case, like I did, link them to Dropbox. How did I get the reticle to float in front of the spaceship? Um, I can show you that when we're done trying to load Mechanim. It's just that I'd forgotten that there's so many scene files involved. What we're looking at is we're loading up all of these crates and models and people and the bear and the sky, and so it's not that Mechanim is that deeper complicated. It's just that these example scenes have a ton of assets in them, um, and we're importing them. So the reticle is based on some code that took me a while to fuss with, and it's drawn using Vectrosity. We're still importing assets. Which draws sort of vector line drawing, which was convenient. It's also how I made the radars using Vectrosity. Vectrosity. Hello. Asset. There we go. Vectrosity. So this is the package that I was using to do a bunch of things in that vector line drawing. Thought you were done. So just back at this one briefly because it's a relatively quick answer. Is that the green circles and the dots, and then the reticle at the front, and then also if I can come out and target something. Oops, change the keys on that one. There we go. That additional one, that's drawn using predictive targeting. So that's sort of the area that I'm supposed to be aiming at rather than the actually at the target. So it's estimating where its position is going to be. So you can see that that's takes a second for it to warm up and get to where it needs to be. Oh, bad guy's on my tail. Oh, let's see if we can come around. Ah, there we go. You can see that that has got a target point in front, and I'll show you the code for that in a second. But if you aim for the predictive targeting, you get some good shots on it. Scripting. It's been so long since I played with this. Is it my UI controller? Speaking of which, this is what I've got going on here is a whoops, come back here. This is you can edit inside Unity, but I think it has a problem when you have two monitors. There we go. So we can do script editing inside Unity with this plugin. And so I'm making, basically, I'm creating a bunch of variables that have dots. And then where's my predictive targeting update? GUI cross. Yeah, I mean, I got a lot of this stuff off of Answers and the forum, looking for solutions for predictive targeting, and some of them worked better than others. And then once I have that set, I then am drawing it. You can also draw them just using little GUI boxes. Like these, some of these are using GUI text and GUI textures, rather than actually using the Vectrosity stuff. Because it was easier for me to temp out really quickly. I'm trying to see if I have something I can actually show that would be of some value. Oops. Oh, interesting, of course. I can't expand it because you can, expand. Oh, there we go. That one works. I think it's just going to be a little bit too hard to break down in a short period of time. And I don't remember this project. It was a Christmas project 2 Christmases ago, and I was tired of having family around the house, so I sat around and made this little project. Sorry to lead you down that and not show it to you, but it's basically you draw points in Vectrosity. So I'm drawing the upper part of the box. And basically, I find the 4 corners of the box and then draw the lines in between them, and then I have a center point that I'm pointing at, and then I figure out where my that it's 2 units up and 2 units over. That's 1 point, 2 units over and 2 units up is the other point. Draw a line between them. Oh, and you can do a lot of these transform points. Sorry, the part of the reason that this works is you can so what you're transforming is you can look at world space and screen space, and you can not only transform points and directions inside the world. So you're doing things like, I want to find out what's in front of my arbitrarily pointing spaceship. What direction is that? Well, in local form, it's straight in front. So it's vector 3 dot forward. But where is that in relation to the real world, to the global space? You can transform points back and forth between local space and world space. And you can transform directions between local space and world space. But you can also you can look at viewpoint to screen point. So you can talk about, your cameras, and you can also look at world to viewpoint. So you can say, I've got a point in my world. Where is it on my screen? So part of what I'm doing with this is I have a target that's 100 meters away from me and off a few yards. But where is that on the screen? And so then I draw a point from the world and I associate it to a point on the screen, and then I draw a box around it on the screen. Because I'm transforming that world to viewport point, and you can also do it to world to camera point. And one of them is normalized, where you can see the camera goes from 0, 0 to 1, 1 if you're doing viewport. And then camera, it's a camera function. You can also do world to screen point, and that's by pixels. So rather than 0 to 1, it's 0 to pixel height, pixel width. And then you can draw things on the screen. Yeah, if you want to generate very simple trains, you could use the mesh class. You could also look at importing raw data and making height maps. Um, this is a bit strange, going to Facebook. And then let me see if I can find what I'm looking for. London Unity Users Group. Come on, go away. Because he was taking come on, where was it? He had a link for taking geodata and putting it into height maps. There it is. So this may be interesting. It may be, it starts off being UK only, so you may have to do some translation, but it talks about how to take height map data and turning it into a height map that you can bring into terrain. So it also depends what you want to do with your simple terrain. Can you apply an alpha mass to a light source? Yes. Oops, let's change back. Okay, this is yesterday's project. I just want to drag this in, just because it's a black and white image. And then I can import that as a cookie. And then I can create a plane, Zorch. And that's our game view. And then let's create a spotlight. Let's reset that, lift that up, and tilt that down. And then let's, ooh, that's doing some weird shit. It's not doing what I expected. Why did that come in as a light map cookie? Is it not black and white enough for you? There we go. And then advanced. silly stuff. Um, it's making a cookie out of it. It's not really working because I don't have the right texture for this. Um, uh, um, but yes, you could bring them in as cookies. And I would actually say that why don't you look at um, lights, and then you can look down at cookies, cube maps around point lights, uh, or um, spotlights. It has to be black along the edges. That's why we're getting this repeat there. But Joel, no, it's still kind of a big mushy thing, and partly where I got stuck on was flocking and obstacle avoidance using Unity steer because I had enemies and I was trying to have them predict where the enemy because right now the enemy is just chasing you like a missile, like a homing missile, and I wanted it to be a little bit more intelligent and then uh, do some avoiding of its neighbors, but still chase after you and simple AI stuff, and I haven't ever gotten it done. There's a thing called Unity Steer, which is very powerful. It's worth taking a look at, but it's not very well documented. And you could look at it here on Argus systems, and I haven't looked in a while. Also, they've got some things on. They also have things on the forum, and essentially they are releasing the code as they use it in their games, but they don't document it. So you have to sort of dig through it, and it doesn't always do what you want it to do. Yeah, I think I should wrap it up. I think it is whiskey time. Um, and like I said, any questions, PM me. But so Little Angel, send me a PM. But preferably, if it's a Unity related question, put a uh, PM me the link to a forum or answers post, and then I'll pay attention to it. And then also, if you have comments or criticisms about this class, that's where you put it. And there's a moderately active see if I can find my subscriptions. Let's see if there's a Unity steer section on the forum as well, but I'm not sure how far. It's not very active because it is one of those things that if you know code, you just read it and you figure it out. If you don't know code, you get intimidated and you run away. And I'm sort of in the middle where I don't know code, but I have yet to be intimidated enough to run away. That's just the discussion, but there's a repository and some other stuff, forked and branched and whatnot that you can download. Woohoo! Well, if you ever figure out Unity steered beyond my pathetic attempts, you can let me know. Yeah, and if you have any questions, I can walk you through specific details of that particular game. And like I said, Vectrosity, it's Vectrosity and Unity Steer and a couple other things, and some simple models made in Blender. Cool. Well, anyway, let me wrap up. I'll see you guys later. See you in the future, maybe on the Learn channel somewhere. Oh, I will. I will. Okay. Talk to you guys later. I'm just going to go ahead and shut down. Deeply appreciated. Till next time.